A warm welcome to you. I'm really glad you're here today. Before we begin, I'd love for you to pop into the comments and let us know where you're listening from and what the local time is for you. It's always beautiful to see how global this little space has become. A big thank you to those who have subscribed and supported by liking videos. It truly helps this channel flourish. And if you'd like me to cover something in the future, your suggestions are always welcome. So now, let's begin. Chapter 1. Exploring the Deep Ocean Environment. The deep ocean, often referred to as the last great frontier on Earth, invites us to explore its vast and mysterious landscape. Stretching beyond the reach of sunlight, this immense habitat covers more than half of our planet's surface and teems with life forms that thrive in conditions that seem unimaginable. As we journey into this realm, we encounter environments that are as diverse as they are enigmatic, revealing secrets held for eons beneath the waves. Imagine descending into the depths, where the light of the sun fades into an eternal twilight. The deep ocean is a world of extremes, characterized by crushing pressures, frigid temperatures, and complete darkness. As we venture deeper, the pressure increases dramatically. At the surface, we are accustomed to one atmosphere of pressure, but in the abyss, it can reach over 1,000 times that amount. This extreme environment is home to creatures that have adapted in remarkable ways. The gelatinous bodies of some deep-sea jellyfish, for instance, are so soft and flexible that they can withstand these immense pressures without collapsing. Temperature, too, plays a crucial role in this alien habitat. The waters of the deep ocean hover around freezing, yet life flourishes in these chilling conditions. Some organisms, like the deep-sea fish known as the abyssal cusk eel, have evolved to produce antifreeze proteins, allowing them to survive without freezing solid. In this realm, every aspect of life is a testament to the resilience of nature. Darkness envelops the deep sea, creating an environment where many creatures rely on bioluminescence. This natural light, produced by organisms such as lanternfish and certain types of plankton, serves various purposes, from attracting mates to luring prey. Imagine the spectacle of a dark ocean lit by the glow of countless creatures, each flickering like stars against the inky backdrop. This phenomenon not only showcases the beauty of the deep, but also highlights the intricate relationships within its ecosystems. The unique features of deep-sea ecosystems are both fascinating and vital to understanding our planet. Hydrothermal vents, for instance, are one of the most intriguing habitats found at the bottom of the ocean. These vents emit superheated water rich in minerals, creating a bizarre oasis of life in an otherwise barren landscape. Here, chemosynthetic bacteria harness chemical energy from the Earth's interior, forming the foundation of a food web that supports a plethora of life forms, including giant tube worms and unique species of shrimp. As marine biologist Sylvia Earle eloquently puts it, the ocean is the heart of our planet. Studying these deep-sea environments is not merely an academic pursuit. It has far-reaching implications for science and humanity. The unique adaptations of deep-sea organisms can inspire innovations in medicine, biotechnology, and environmental science. For example, the enzymes found in Extremophiles, organisms that thrive in extreme conditions, are being researched for their potential in industrial applications, from biofuels to pharmaceuticals. The deep sea holds untapped resources that may offer solutions to some of our most pressing challenges. Moreover, understanding the deep ocean is essential for grasping the interconnectedness of all ecosystems. The oceans regulate the Earth's climate and play a critical role in the carbon cycle. One might wonder how the health of the deep sea impacts our lives on land. The answer lies in the delicate balance of marine ecosystems. Disruptions in deep-sea habitats can have cascading effects, influencing weather patterns, sea levels, and even the availability of food resources. As we contemplate the significance of exploring the deep ocean environment, we must also recognize the challenges that come with it. The vastness of this realm presents logistical difficulties and technological hurdles. Yet, with advancements in deep-sea exploration technologies, such as remotely operated vehicles and manned submersibles, we are gradually unveiling the mysteries hidden beneath the waves. Each discovery adds to our understanding of how life adapts and thrives in the most extreme conditions on Earth. In this journey through the deep ocean, we not only uncover the wonders of its ecosystems, but also gain insight into the resilience of life itself. The creatures that inhabit this abyssal world remind us that life can flourish in the most unexpected places, challenging our perceptions of what is possible. As we proceed, we open our minds to the possibilities that lie ahead, exploring the depths of our planet with curiosity and awe. As we delve further into this unexplored domain, we come upon the phenomenon of deep-sea coral reefs, often described as the rainforests of the ocean. Unlike their shallow-water counterparts, these coral gardens thrive in the dark depths, providing essential habitats for various marine species. The cold-water corals, such as Lophelia pertusa, are particularly fascinating. These corals grow slowly, some only a few millimeters a year, yet they can live for centuries, forming intricate structures that serve as vital ecosystems. Visualize a sprawling underwater landscape dotted with these ancient coral formations, where fish find refuge among the branches and invertebrates cling to the surfaces. The biodiversity supported by cold-water coral reefs is astounding, with many species still unidentified. The intricate relationships among these organisms reflect the delicate balance of life in the deep sea. As marine ecologist Dr. Ayanna Elizabeth Johnson once remarked, "The ocean is a symphony, and each species plays a unique role in the harmony of life." In addition to coral ecosystems, we encounter the enigmatic deep-sea trenches, the deepest places on Earth, where the ocean floor drops to staggering depths. The Mariana Trench, for example, is a site of extreme isolation and pressure. Here, life adapts in ways that seem almost like science fiction. Bathymodiolus mussels, for instance, can filter nutrients from the water and are often found near hydrothermal vents, where they engage in symbiotic relationships with chemosynthetic bacteria. These bacteria convert the chemicals from the vent into energy, providing sustenance for the mussels and other organisms in this uniquely harsh environment. One cannot help but wonder how life persists in such desolate places. The organisms that inhabit these trenches have evolved remarkable adaptations, including specialized physical structures and biochemical processes that allow them to withstand immense pressure and cold temperatures. These adaptations offer a glimpse into the resilience of life, showcasing the endless possibilities of evolution in response to extreme environments. The exploration of these deep-sea trenches has opened new avenues of research, revealing not only the extraordinary life forms that exist within them, but also the geological processes that shape our planet. The study of subduction zones, where tectonic plates collide and one plate is forced beneath another, illuminates how these formations contribute to our understanding of Earth's history. Each trench holds clues to the processes that have formed and transformed our oceans, offering insights into seismic activity and the movement of tectonic plates. As we continue our journey, it becomes evident that the deep ocean is not merely a repository of unique life forms, but also a vital component of Earth's climate system. The deep sea plays a crucial role in the carbon cycle, sequestering carbon dioxide from the atmosphere and regulating global temperatures. Phytoplankton, microscopic plants that inhabit the surface waters, capture carbon during photosynthesis. When they die, they sink to the depths, carrying carbon with them. This natural process helps mitigate climate change, yet it remains under threat from human activity. Imagine the vast networks of life, from the tiniest plankton to the largest whales, all interconnected in a complex web that supports the health of our planet. The importance of maintaining these ecosystems cannot be overstated. Marine biologist and conservationist Oceana asserts, "The ocean is the blue heart of our planet." Protecting the deep sea is essential not only for its inhabitants, but also for the health of all life on Earth. Yet paradoxically, the deep ocean faces numerous threats, including pollution, overfishing, and climate change. The impacts of these activities reach far beyond the ocean floor, affecting global ecosystems and human communities alike. As we confront these challenges, the urgency for research and conservation becomes more apparent. By unlocking the secrets of the deep sea, we can better understand the effects of human actions and develop strategies to safeguard these vital ecosystems. The pursuit of knowledge in this field is not solely for the benefit of humanity. It is a quest for understanding the intricate connections that bind all life. As we explore the depths, we are reminded of the wisdom of oceanographer Jacques Cousteau, who declared, "The sea, once it casts its spell, holds one in its net of wonder forever." This wonder propels scientists and explorers alike to uncover the mysteries of the deep, igniting a passion for discovery that transcends generations. In this endeavor, cutting-edge technology plays a pivotal role. With the advent of autonomous underwater vehicles and advanced imaging techniques, researchers can now explore territories previously thought unreachable. These innovations allow us to capture stunning visuals of the deep-sea life, revealing the extraordinary beauty that lies beneath the surface. Each expedition brings new revelations, expanding our understanding of biodiversity in the ocean and how it can be preserved. As we reflect on the significance of studying the deep ocean, we recognize that it is a mirror reflecting our own existence. The deep sea challenges our perceptions of life, resilience, and interconnectedness. Each discovery prompts questions that inspire curiosity and drive further exploration. What other wonders lie hidden beneath the waves, waiting to be unveiled? What stories do the inhabitants of the deep ocean have to tell us about survival and adaptation in the face of adversity? As we continue to traverse this uncharted territory, we are not merely observers, we become stewards of the ocean. The responsibility to protect these fragile ecosystems rests upon our shoulders. By fostering a deeper understanding of the deep sea, we cultivate a sense of respect and reverence for the intricate web of life that sustains our planet. The journey into the depths is not just a scientific expedition. It is a call to action, urging us to preserve the wonders of the deep ocean for generations to come. As we immerse ourselves in the exploration of the deep ocean, we cannot overlook the role of deep-sea ecosystems in supporting global biodiversity. The unique adaptations of organisms found in these depths are not just marvels of nature. They also hold vital information about resilience and adaptability that can inform our understanding of life on Earth. For example, the unique properties of deep-sea fish, like the anglerfish, with its bioluminescent lure, demonstrate how life can evolve ingenious strategies for survival in a world of darkness and scarcity. Envision the anglerfish, its flickering light drawing an unsuspecting prey in the vast dark. This fascinating predator, with its grotesque appearance, embodies the extraordinary survival tactics that have emerged in this harsh environment. The adaptations of such creatures raise intriguing questions about the evolutionary pressures they face. What drives these adaptations, and how do they inform our broader understanding of evolution itself? The deep sea also provides a living laboratory for studying the impacts of climate change. As ocean temperatures rise and acidity increases, scientists are racing against time to understand how these profound changes will affect deep-sea ecosystems. The coral reefs and hydrothermal vents that harbor such diversity are particularly vulnerable. Imagine the delicate balance of life that could be disrupted, leading to cascading effects throughout the marine food web. As we consider the fragile nature of these ecosystems, we are reminded of the insight offered by oceanographer Sylvia Earle, who said, "With every drop of water you drink, every breath you take, you're connected to the sea." This connection highlights the importance of protecting the deep ocean, as its health directly impacts our own. Furthermore, studying the deep ocean can lead to discoveries that enhance our understanding of disease resistance, biotechnology, and even climate resilience. Extremophiles, the organisms that thrive in the most inhospitable conditions, are of particular interest. They produce unique compounds that have potential applications in medicine, from developing new antibiotics to creating robust enzymes used in industrial processes. Imagine the potential breakthroughs that could arise from these remarkable organisms. It's a testament to the idea that the most unexpected places can yield the most promising solutions. The deep sea is a treasure trove of possibilities, waiting to be explored and understood. As we delve deeper into this realm, we must also acknowledge the cultural significance of the ocean. Many coastal communities have deep-rooted connections to the sea, relying on it for sustenance and livelihoods. Their knowledge, passed down through generations, is invaluable in understanding the intricate relationships between humans and marine ecosystems. By incorporating traditional ecological knowledge into modern scientific practices, we can foster a holistic approach to ocean conservation. The interplay between scientific exploration and cultural understanding enriches our perception of the deep ocean. It reminds us that the quest for knowledge is not solely a scientific endeavor. It is also a journey of respect and coexistence with the natural world. In this vast oceanic expanse, there are still countless mysteries to unravel. The ocean floor remains largely unexplored, with vast areas yet to be mapped. Each expedition offers the promise of new species and ecosystems waiting to be discovered, each one a piece of the intricate puzzle that is our planet's biodiversity. As we reflect on the importance of this exploration, we are encouraged to consider the legacy we wish to leave behind. What stories do we want future generations to tell about our relationship with the deep ocean? The responsibility to protect and preserve these hidden wonders is a shared one. It calls for collaboration among scientists, policymakers, and communities to ensure that the deep sea remains a source of inspiration and discovery for years to come. In the heart of the deep ocean, we find an invitation to wonder and to act. The journey into these depths is not merely an exploration of the unknown, but a profound opportunity to learn from the resilience of life itself. As we embrace this journey, we open our hearts and minds to the beauty and complexity of the deep sea, committed to safeguarding its future. Chapter 2: Bioluminescence, Nature's Underwater Light Show. Bioluminescence is a captivating phenomenon, a natural light show that graces the darkened depths of the ocean. This enchanting ability to produce light is found in various organisms, from microscopic plankton to the majestic jellyfish. Bioluminescence is not merely a spectacle. It is a complex biochemical process that unfolds in the bodies of these creatures. At its core, bioluminescence occurs when luciferin, a light-emitting molecule, interacts with the enzyme luciferase. This reaction produces light, often in shades of blue and green, which travel efficiently through water. Imagine the gentle glow of a lantern illuminating the shadows of the deep. This is the essence of bioluminescence, a beacon in an otherwise pitch-black environment. Consider the anglerfish, a master of disguise and ingenuity in the deep ocean. Equipped with a bioluminescent lure that dangles from its head, this fish attracts unsuspecting prey. The light, shimmering softly in the darkness, acts as a siren's call, drawing creatures closer until they are within striking distance. This adaptation exemplifies how bioluminescence serves a vital role in the survival of species dwelling in the deep. The anglerfish's unique ability allows it to thrive in an environment where competition for food can be fierce and resources scarce. As we explore further, the enchanting world of bioluminescence reveals other remarkable inhabitants. The deep-sea jellyfish, for instance, displays an ethereal glow, illuminating its gelatinous body as it drifts through the water. Some species, like the firefly squid, produce flashes of light in a dazzling display. This spectacle is not merely for show, it plays a crucial role in communication. In the depths, where vision is limited, these light displays serve as signals to potential mates or rivals. Imagine a hidden ballroom, where partners twirl and glide, illuminated only by the soft glow of their own bodies. The role of bioluminescence extends beyond communication. It also plays a pivotal part in the intricate web of predator and prey. Certain creatures utilize this glowing ability as a defense mechanism. The lanternfish, for example, can produce a burst of light to confuse predators, allowing it to escape into the shadows. This clever tactic provides a moment's advantage, a fleeting opportunity to slip away into the darkness. In the deep-sea ecosystem, bioluminescence is not just a curious trait, it is a fundamental aspect of life. The organisms that inhabit these depths often rely on the light produced by their neighbors for various survival strategies. Imagine a vibrant community where each flicker and glow contributes to the collective narrative of life in the abyss. From the smallest plankton to the largest predators, bioluminescent signals interweave, creating a complex and dynamic environment. The significance of bioluminescence stretches beyond individual interactions. In the vast expanse of the ocean, light plays a crucial role in nutrient cycling. As bioluminescent organisms die, their bodies decompose, releasing nutrients back into the water column. This process sustains life, feeding the next generation of creatures that will inhabit these depths. It is a continuous cycle, where light and life are intertwined, illuminating the dark water in a symphony of existence. The phenomenon of bioluminescence has not only captivated scientists, but has also inspired countless researchers in their quest to understand its mysteries. The pioneering work of luminaries like Osamu Shimomura, who studied the bioluminescence of the jellyfish Equoria victoria, has brought us closer to unraveling the secrets of this enchanting light. Shimomura's discoveries have paved the way for advancements in fields such as molecular biology and bioengineering, where the green fluorescent protein derived from this jellyfish has become a crucial tool in scientific research. "Nature is full of genius," he once said, "but it has not yet captured the light of the stars." The light of bioluminescent organisms offers a glimpse into nature's ingenuity, illuminating pathways for future discoveries. As we venture deeper into the ocean's depths, we may wonder how bioluminescence influences our understanding of marine environments. In the abyss, vast stretches of darkness are punctuated by bursts of light, revealing hidden ecosystems that thrive far from sunlight. Bioluminescent organisms are essential indicators of ecological health, serving as barometers for changes in marine environments. Scientists have begun to harness the power of these glowing creatures to monitor oceanic conditions, utilizing their light as a signal for shifts in temperature, chemistry, or even the presence of pollutants. Imagine the vast ocean, where the light emitted by these organisms not only enchants, but also informs us of the health of our planet. The intricate dance of bioluminescence embodies the interconnectedness of life and the environment, reminding us that even in the deepest darkness, light persists. As we reflect on the role of bioluminescence in the ocean's ecosystems, a deeper appreciation for these remarkable adaptations emerges. Each light flicker tells a story, each glow serves a purpose. In the deep sea, where life thrives against all odds, bioluminescence becomes a symbol of resilience and ingenuity. The interplay of light and shadow in this submerged realm invites us to ponder the mysteries that lie beneath the surface. How many more secrets await discovery in the dark corners of the ocean? The stories of bioluminescent creatures are just beginning, and their glowing presence continues to illuminate the paths of exploration and understanding. In our journey through the vastness of the ocean, we are reminded that bioluminescence is not merely a biological curiosity. It is a testament to the wonders of evolution and adaptation. The creatures that call the deep sea home have developed extraordinary strategies to navigate their dark world. Their glowing bodies transcend the mundane, transforming the deep ocean into a living canvas of light and life. As we continue to explore, we are left with a sense of awe, captivated by the remarkable ways in which nature reveals its beauty in the most unexpected forms. In this remarkable underwater realm, bioluminescence serves as a vital thread woven into the fabric of life. As we encounter the myriad of bioluminescent organisms, we unveil a world where light not only enchants, but also sustains. Imagine the collective symphony of glowing bodies, harmonizing in the inky waters. Each organism contributes its unique frequency, creating a mesmerizing display that dances across the ocean floor. Consider the vibrant world of dinoflagellates, single-celled organisms that are often responsible for the sparkling phenomenon seen in waves crashing against the shore. As they are disturbed, either by a passing fish or the movement of water, they emit light in a stunning display. This bioluminescent response is a survival tactic, a method of deterring predators by startling them with sudden bursts of light. Imagine standing on a beach, witnessing the surf illuminated by a cascade of glittering blue, as the dinoflagellates react to the rhythm of the waves. This natural spectacle connects us to the ocean's heartbeat, reminding us of the intricate relationships formed in the depths. The deep-sea ecosystems thrive on these glowing interactions. In this dark realm, bioluminescence plays a fundamental role in the food web. Predators and prey engage in a complex game of hide and seek, where the flicker of light can mean the difference between life and death. Take the case of the deep-sea squid, which utilizes its bioluminescent capabilities to both lure prey and evade capture. With a flick of its chromatophores, it can manipulate its color and light, blending into the dark ocean backdrop or sparkling like a star. This adaptability showcases the remarkable evolutionary pressures that have shaped these creatures, compelling them to master the art of light in a world devoid of sunshine. As we continue to explore these depths, we find that bioluminescence is also a form of communication among species. The luminous displays of certain jellyfish, for instance, can signal distress, attracting attention from potential mates or warning rivals. This method of signaling is particularly effective in the vast expanse of the ocean, where visual cues are often lost. Imagine an intricate conversation unfolding in the deep, where each glow conveys a message, each flicker whispers a secret. The language of light is universal, transcending species and connecting a community of life forms in a shared silent dialogue. In the broader context of deep-sea ecosystems, bioluminescence plays a crucial role in nutrient cycling and energy transfer. As organisms use light to communicate, attract prey, or evade threats, they also contribute to the overall health of their environment. The organic matter produced by bioluminescent creatures, including their waste and decomposing bodies, enriches the surrounding waters with vital nutrients. These nutrients serve as the foundation for other life forms, creating a web of interdependence that sustains the diverse inhabitants of the deep. Consider the role of bioluminescence in the context of climate change. As ocean temperatures rise and ecosystems shift, the health of bioluminescent organisms can offer insights into the changes occurring in these environments. Scientists are increasingly focusing on these glowing indicators to monitor the impacts of human activity on marine life. Imagine a future where we can harness this natural light to assess the health of our oceans, using the very organisms that illuminate the dark to guide our understanding and conservation efforts. The stories of bioluminescent creatures do not cease to inspire curiosity and wonder. Researchers, driven by a passion for unraveling the mysteries of life beneath the waves, continue to make incredible discoveries. Scientists like Edward E. Whittaker have dedicated their careers to studying the complex interactions of bioluminescent organisms, revealing insights into the genetic foundations of this extraordinary ability. Their work underscores the significance of bioluminescence as a tool for understanding not just individual species, but the intricate networks that sustain entire ecosystems. In the words of one researcher, the ocean is an extraordinary laboratory of life. Each study into bioluminescence adds depth to our understanding of this vast biome, revealing the delicate balance that sustains life in the deep. The interplay of light and biology invites us to explore further, to ask questions about the future of these remarkable adaptations. What will happen to bioluminescent organisms as their environments evolve? How will changes in ocean chemistry and temperature affect their dazzling displays? As we ponder these questions, we recognize our role in this narrative, our responsibility to safeguard the wonders of the ocean. As we move through the mysteries of bioluminescence, we find ourselves captivated by the stories that unfold in the dark. Each flicker of light serves as a reminder of the resilience of life, even in the most extreme conditions. The ocean, with its hidden wonders, beckons us to delve deeper, to uncover the secrets held within the shimmering glow of its inhabitants. In this enchanting underwater light show, we discover not only the marvels of nature, but also our profound connection to the vastness of life beneath the waves. In the depths of the ocean, the interplay of bioluminescence reveals a hidden world that thrives in the absence of sunlight. Here, life has evolved ingenious adaptations, allowing organisms to harness light for survival in ways that often seem otherworldly. For instance, the deep-sea anglerfish not only uses its bioluminescent lure to attract prey, but also has developed the ability to change the intensity and color of its light, adapting its strategy based on the types of creatures it aims to ensnare. This remarkable flexibility demonstrates the intricate relationship between bioluminescence and the ecological dynamics of the deep sea. As we consider the vast array of bioluminescent species, it becomes evident that these adaptations are not simply decorative. The light produced by organisms like the glowing plankton is often a byproduct of their metabolic processes, acting as a beacon in the dark waters. Predators and prey alike have evolved alongside these luminous beings, with many species relying on the flickering light as a means of identification and communication. Imagine the deep sea as a grand stage, where each organism plays its role in an elaborate performance of survival. The role of bioluminescence extends beyond individual interactions, influencing entire ecosystems. In the deep, where food is often scarce, bioluminescent organisms serve as pivotal players in nutrient cycling. The organic matter they produce enriches the surrounding waters, feeding a plethora of other species. The remains of bioluminescent creatures that drift to the ocean floor become sustenance for scavengers, creating a cycle of life that is interconnected and vibrant. This process allows for a thriving community, where every organism contributes to the greater whole. In this realm, the phenomenon of bioluminescence also serves as a tool for scientists investigating the health of marine ecosystems. As researchers delve into the complexities of these luminous organisms, they uncover patterns that reveal shifts in environmental conditions. For example, a decline in bioluminescent populations may signal changes in water quality or temperature, providing vital clues about the state of the ecosystem. This ability to act as early warning signs highlights the importance of bioluminescent organisms in our understanding of ocean health. Consider the incredible bioluminescent phenomenon that occurs during a deep-sea migration, where vast schools of fish light up the depths, creating a breathtaking spectacle. This migration is not just a spectacle of beauty, it is a critical event in the life cycles of these species. As they move, their bioluminescent displays attract predators, while also facilitating communication among themselves. This dual role of light as both a lure and a signal exemplifies the delicate balance of life in these dark waters. The study of bioluminescence has led to fascinating discoveries beyond the ocean's depths. Scientists have begun to explore the potential applications of bioluminescent proteins in fields such as medicine and biotechnology. From tracking cellular processes to developing innovative imaging techniques, the insights gained from these glowing organisms have far-reaching implications. Each discovery echoes the sentiment of the great biologist, who once observed that the more we explore, the more we find that nature has solutions that we have yet to understand. The stories of bioluminescent creatures are woven into the fabric of our understanding of marine environments. With each new finding, we are reminded of the importance of preserving these ecosystems. The delicate balance of life beneath the waves is easily disrupted, and as stewards of the planet, we must remain vigilant in our efforts to protect these remarkable environments. As we continue to explore the intricacies of bioluminescence, we marvel at the beauty and complexity of life in the deep sea. Each organism, with its unique light-producing capabilities, contributes to a larger narrative of existence in the darkness. The ocean, with its vastness and mysteries, invites us to ponder our place within this intricate web of life. How can we harness our understanding of bioluminescence to foster a greater appreciation for the wonders of the natural world? In this journey through the depths, we are left with a sense of wonder and a desire to uncover more about the enchanting light shows that grace the ocean floor. Each glimmering organism tells a story, urging us to look closer and listen more intently to the whispers of the deep. The luminous dance of life in the ocean is a testament to nature's resilience, creativity, and the endless possibilities that await discovery. Chapter 3: Unique Feeding Strategies of Deep-Sea Creatures. In the heart of the deep sea, where sunlight dares not penetrate and the pressure mounts like an unyielding force, life has found a way to flourish against all odds. The creatures that inhabit this profound abyss have evolved remarkable feeding adaptations, sculpted by the extreme conditions they endure. These adaptations are not merely survival mechanisms, they are fascinating strategies that unveil the ingenuity of nature. Imagine a world where food is as scarce as light, a realm where the art of feeding becomes a game of patience, precision, and creativity. In this hidden depth, filter feeding emerges as a prominent strategy employed by many organisms. Some of the most graceful giants of the ocean, like the basking shark and the whale shark, glide through the water with their mouths agape, filtering out tiny plankton and other minuscule organisms that drift through their path. The mechanics of filter feeding in these titans is a marvel in itself. Their gill rakers, specialized structures that resemble combs, trap the microscopic prey while allowing water to flow freely through, enabling them to consume vast quantities with each majestic sweep. This technique is not limited to the largest creatures. Smaller organisms, like certain species of jellyfish, also utilize a form of filter feeding. Their delicate, umbrella-like bodies pulse gently, creating currents that draw in the surrounding water, laden with nutrients. Consider the beauty of this method. As the water moves through the filtering apparatus, it carries with it the essence of life, sustaining these beings in a world where food sources are scattered and fleeting. The gentle rhythm of their feeding reflects a profound harmony with their environment, highlighting the intricate balance of the deep-sea ecosystem. Yet, not all creatures in the abyss rely on passive measures. The predatory strategies employed by various deep-sea inhabitants speak of a world where cunning and stealth reign supreme. Ambush tactics come to life, revealing the darker side of the ocean's banquet. Take, for example, the enigmatic deep-sea anglerfish. With its bioluminescent lure dangling enticingly from its forehead, it embodies the art of seduction in the depths. The soft glow attracts unsuspecting prey, luring them into a trap. When the moment is right, the anglerfish strikes with incredible speed, its jaws expanding to consume its bewildered meal. The anglerfish is not alone in its predatory prowess. The deep sea is home to a host of creatures that have honed their ambush strategies to perfection. The gulper eel, with its enormous mouth and expandable stomach, can engulf prey much larger than itself. Picture this creature lying in wait, its elongated body camouflaged against the inky backdrop of the abyss. When a small fish or squid ventures too close, the gulper eel springs into action, capturing its meal in an instant. It is a striking reminder of how adaptation can take many forms, each designed for survival in a world where opportunities for nourishment are fleeting. Luring and ambushing are not the only strategies that define the feeding behaviors of deep-sea creatures. Scavenging plays a crucial role in the food webs of this dark realm. In a landscape where death is a constant, the remains of fallen creatures provide a vital resource. Imagine the scene, the carcass of a once mighty whale drifting slowly to the ocean floor. This massive offering becomes a feast for a diverse array of scavengers, from tiny amphipods to colossal deep-sea sharks. These scavengers are nature's recyclers, breaking down organic matter and redistributing nutrients throughout the ecosystem. The process of scavenging is not simply an act of survival, it is a complex interaction that sustains life. In fact, as marine biologist Dr. Sylvia Earle observed, the ocean is a source of life, and we must learn to live with it rather than against it. This sentiment captures the essence of how scavengers fulfill their ecological role, ensuring that nothing goes to waste. The feeding strategies of deep-sea creatures are as unique as the environments they inhabit. The adaptations that allow them to thrive are a testament to the resilience of life in extreme conditions. Each strategy tells a story of survival, ingenuity, and the delicate balance of life beneath the waves. As we continue to explore the depths of the ocean, we uncover not only how these remarkable creatures obtain their sustenance, but also how their feeding behaviors are intricately woven into the broader tapestry of oceanic life. The cycles of predation, scavenging, and filtering are interdependent, forming a network that supports the diverse inhabitants of this hidden world. Through this journey into the feeding adaptations of deep-sea creatures, we begin to appreciate the profound connections that exist within the ocean's depths. Each creature, from the largest filter feeder to the stealthiest predator, plays a role in maintaining the delicate equilibrium of life in the abyss. The mysteries of the deep continue to invite our curiosity, beckoning us to learn more about the extraordinary strategies that sustain life in one of the most extreme environments on our planet. As we venture further into the depths, we encounter an astonishing variety of feeding adaptations that allow creatures to exploit the scarce resources available in such a challenging environment. The deep sea is not only home to filter feeders and ambush predators. It also harbors a myriad of scavengers that play a critical role in the intricate web of life beneath the waves. Imagine the scene. A feast has been laid out on the seabed, the remains of a giant squid, its once vibrant colors muted in death. This banquet attracts a multitude of scavengers, each with its own unique adaptations for capitalizing on the nutrient-rich bounty. Among them, the deep-sea scavenger, the amphipod, emerges as a remarkable example. These small, shrimp-like creatures possess specialized mouthparts that enable them to tear apart the decaying flesh, efficiently processing the organic matter that drifts down from the surface. Scavenging is not a solitary endeavor. It is a communal act, often drawing a congregation of different species. The sight of a cluster of deep-sea fish, alongside crustaceans and even larger predators, feasting on a carcass is a testament to the interdependence of life in this dark realm. Such gatherings highlight how scavengers not only consume, but also contribute to the cycle of life and death, ensuring that nutrients are recycled back into the ecosystem. One cannot help but marvel at the resilience of life in these depths. With food sources often unpredictable, many deep-sea scavengers have developed a highly efficient metabolism, allowing them to survive on minimal nourishment. This adaptation speaks to the broader theme of survival in the ocean's depths, where every calorie counts. As oceanographer Dr. David Carl eloquently stated, life in the ocean is about survival, adaptation, and resilience. Yet, scavenging behaviors extend beyond mere opportunism. Certain species have evolved strategies to detect carcasses from great distances, using chemical cues released during decomposition. The ability to sense these signals in the dark, cold waters reveals an extraordinary adaptation that highlights the interconnectedness of deep-sea life. Imagine how a scavenger might detect a feast from miles away, its senses finely tuned to the subtle changes in the chemical landscape of the ocean. As we delve deeper into the feeding strategies of these creatures, we come across the fascinating adaptations of the deep-sea hagfish. Often overlooked, these jawless fish are remarkable scavengers, known for their ability to consume carrion much larger than themselves. Their unique feeding mechanism involves an incredible ability to produce copious amounts of slime, which serves to immobilize larger prey and provides a means of defense against potential threats. Picture the hagfish wrapping itself around a carcass, its body undulating as it feeds, a living testament to the wonders of nature's ingenuity. The role of scavengers is not limited to feeding on dead organic matter. They also participate in the process of nutrient cycling. Decomposing bodies release vital elements back into the ecosystem, enriching the surrounding waters. These nutrients, in turn, fuel the growth of phytoplankton, the foundation of the oceanic food web. In this way, scavengers contribute not just to their own survival, but also to the broader health of the marine environment. Consider the symbiotic relationships that arise in these feeding behaviors. Some scavengers, such as the cookie cutter shark, employ a unique strategy of feeding that involves taking bites out of larger creatures. This predatory approach not only provides sustenance for the shark, but also creates opportunities for other scavengers to feast on the remains left behind. The cookie-cutter sharks method exemplifies the delicate balance maintained within the ecosystem, where each interaction has far-reaching consequences. As we reflect on these diverse feeding strategies, we come to appreciate the delicate interplay of life in the deep sea. Each creature, whether a filter feeder, an ambush predator, or a scavenger, plays a critical role in sustaining the intricate web of life. The ocean's depths, often perceived as barren and hostile, are in fact bustling with activity, each organism contributing to the collective health of this mysterious habitat. The unique adaptations found within the deep sea serve as a reminder of nature's resilience and creativity. The remarkable variety of feeding strategies illuminates the complexity of life beneath the waves, inviting us to ponder the endless possibilities of survival in an environment where light is scarce and the pressures are immense. As we continue our exploration, we find that the deep sea is not merely a realm of isolation. It is a vibrant network of life, each thread woven together in a magnificent tapestry of existence. In this world, where darkness reigns and food is a precious commodity, the ingenuity of deep-sea creatures shines through. They remind us that life can thrive even in the most extreme conditions, driven by an innate desire to survive and adapt. The journey into the depths of the ocean reveals not only the fascinating feeding strategies of its inhabitants, but also the profound connections that bind them together, all playing their part in the symphony of life that echoes through the dark waters. The depth of the ocean not only harbors extraordinary feeding strategies, but also showcases the resilience and adaptability of life forms that thrive where few would expect. Among these remarkable beings, the scavengers play a pivotal role, acting as nature's cleanup crew. Their importance in the ecosystem cannot be overstated, as they ensure that nutrients are recycled and available for other marine life. Imagine the eerie silence of the deep sea, punctuated only by the gentle currents that slowly carry particles of organic matter. In this vast darkness, the scavengers emerge, often unseen but ever-present. Some, like the polychaete worms, have developed specialized adaptations to maximize their foraging success. With bristle-like appendages, they can cling to the remains of decaying organisms, extracting every ounce of nourishment available. These creatures exemplify the idea that life can adapt to even the harshest conditions, utilizing every possible resource to thrive. In the realm of scavenging, the deep sea is rich with variety. Consider the fascinating case of the deep-sea starfish, which employs a unique feeding technique. When a starfish encounters a carcass, it can extend its stomach out of its body, enveloping the decaying matter and digesting it externally. This remarkable ability allows the starfish to consume prey that would otherwise be too large to ingest whole. It is a striking example of adaptation, showcasing how life finds ingenious solutions to challenges posed by the environment. The interactions among scavengers can be as intricate as their feeding strategies. When a large carcass descends to the ocean floor, it creates a flurry of activity as various species converge. The spectacle of a congregation of different scavengers, each vying for a share of the bounty, highlights the interconnectedness of these creatures. It is a vivid reminder of how survival often hinges on cooperation and competition, intertwining their fates in the depths of the ocean. The role of scavengers extends beyond mere consumption. They are integral to the nutrient cycling that sustains the ecosystem. As they break down organic matter, they release essential nutrients back into the water, fostering the growth of phytoplankton and other primary producers. This cycle is crucial, as it creates a foundation for the entire food web, demonstrating that every creature, no matter how small, contributes to the broader health of the ocean. Imagine the pulse of life that underlies these interactions, an ebb and flow of energy that connects all beings in the deep sea. The scavengers, in their relentless pursuit of sustenance, embody the spirit of resilience that defines this environment. They remind us that life, even in its most challenging forms, persists through adaptation and collaboration. As we consider the remarkable feeding adaptations of deep-sea creatures, we find ourselves drawn into a world rich with complexity and wonder. The delicate balance between predator and prey, scavenger and decomposer, creates a vibrant ecosystem that thrives in the most unexpected of places. Each feeding strategy illuminates a facet of life beneath the waves, offering insights into the remarkable interplay of existence in the depths of the ocean. The unique feeding strategies of deep-sea organisms serve as a testament to the ingenuity of life. They illustrate how, in a realm characterized by darkness and scarcity, creatures have evolved to exploit every opportunity. As we continue to explore these depths, we gain a deeper appreciation for the intricate web of life that flourishes in the shadows, where survival is an art form and every strategy is a masterpiece of nature's design. Chapter 4: Camouflage and Mimicry, Survival Tactics. In the unfathomable depths of the ocean, where light is but a fleeting memory and the environment is harsh and unyielding, the art of survival takes on remarkable forms. Camouflage and mimicry become more than mere tactics. They are essential lifelines in the intricate web of predator-prey interactions. Imagine yourself submerged in this world, where colors and shapes blend seamlessly with the surroundings, and every movement is a calculated risk. The ability to remain unseen, to slip between the shadows like a whisper, can mean the difference between life and death. One of the most striking examples of camouflage can be found among deep-sea creatures. Picture the octopus, a true master of disguise. With its exceptional ability to change not only its color, but also its texture, the octopus can transform its appearance to match the rocky crevices or sandy seabeds it inhabits. As it glides through the water, the octopus can mimic the patterns of the ocean floor, rendering it almost invisible to both prey and predators alike. This remarkable adaptation is not merely a product of instinct. It is a sophisticated interplay of neural control and environmental awareness. Researchers have observed that the octopus can alter its appearance in mere moments, a testament to its intelligence and adaptability. The cuttlefish, a close relative, employs similar strategies, but adds an extra layer of complexity with its rapid color-changing capabilities. With chromatophores, tiny pigment cells that expand and contract, the cuttlefish can create vibrant displays or blend into its surroundings in the blink of an eye. It moves through the water like a fluid shadow, evading the gaze of curious predators. Imagine the thrill of observing such a performance, where every flicker of color tells a story of survival. In the abyssal plains, we encounter creatures that have evolved unique camouflage techniques suited for their dark surroundings. The deep-sea anglerfish, for instance, has developed a fascinating adaptation that combines bioluminescence with camouflage. Its bioluminescent lure not only attracts prey, but also disguises its presence in the inky void. This strategic use of light serves as both a beacon and a veil, allowing the anglerfish to remain concealed while enticing unsuspecting creatures to swim closer. Mimicry, on the other hand, takes the art of deception a step further. It involves not just blending in, but rather imitating the appearance or behavior of other organisms. This strategy can be particularly effective in a world where dangers lurk in every shadow. Consider the mimic octopus, which can impersonate several species, including the lionfish and the flatfish, through changes in color and posture. By mimicking these potentially dangerous creatures, the mimic octopus effectively deters predators. This extraordinary ability showcases the intelligence and adaptability of life in the deep ocean, where survival often hinges on the ability to outwit adversaries. Then there are the harmless mimic species, such as the scarlet king snake, which adopts the coloration of the venomous coral snake. This mimicry provides a significant advantage, as potential predators often avoid the king snake, mistaking it for its more dangerous lookalike. Such adaptations illustrate the intricate relationships that exist within ecosystems, highlighting the delicate balance between predator and prey. These sophisticated survival tactics profoundly influence species interactions and the dynamics of deep-sea ecosystems. Camouflage and mimicry can alter food webs, for they affect how predators hunt and how prey evade capture. When a species evolves to become more adept at blending in or mimicking another, it can shift the balance of power in the depths, impacting not only its own survival, but that of countless others. Imagine a bustling coral reef, where vibrant colors and patterns create a stunning visual feast. Amidst this beauty, myriad creatures rely on these tactics to thrive. The butterfly fish, with its striking hues, often finds refuge among the coral, where its own colors reflect the environment, making it harder for predators to spot. Here, camouflage morphs into a vital survival strategy, showcasing nature's artistry in a world of color and contrast. The pelagic zone, marked by open waters and an ever-shifting landscape, presents its own challenges. Creatures like the transparent jellyfish and the ghost shrimp employ transparency as their primary means of camouflage. By allowing light to pass through their bodies, they become nearly imperceptible against the backdrop of their surroundings. This adaptation is particularly crucial in an environment where potential threats can come from any direction. The ghost shrimp, for instance, relies on its ethereal quality to evade predators while hunting for food among the ocean floor's detritus. As we explore these adaptations further, we may wonder, how does the complexity of these survival strategies shape the relationships between species? The answer lies in the delicate balance of interactions that define the deep ocean. Predators become more adept at hunting, while prey evolve to outsmart them, creating a continuous cycle of adaptation and counter-adaptation. This interplay extends beyond the realm of individual species, influencing entire ecosystems. When a particular species develops effective camouflage or mimicry, it can lead to shifts in population dynamics, altering the way energy flows through the food web. For instance, if a predator becomes more efficient at locating camouflaged prey, it may result in a decline in that prey's population, prompting shifts in the behaviors of other species that rely on it for sustenance. Consider the fascinating case of the vampire squid, a creature that thrives in the dark, cold depths of the ocean, where it employs both camouflage and bioluminescence. By using its unique ability to emit light, it can create a dazzling display that confuses potential predators while remaining concealed in the shadows. This dual strategy allows the vampire squid to navigate its environment with a sense of security, showcasing the profound ways in which adaptation can influence survival. As we delve deeper into the mysteries of camouflage and mimicry, we begin to realize that these adaptations are not merely tricks of nature, but rather intricate survival tactics honed over countless generations. They illustrate the beauty and complexity of life in the deep ocean, revealing how organisms can thrive in a world that seems inhospitable at first glance. In the end, the stories etched in the patterns of these creatures reflect the broader narrative of resilience and ingenuity that defines life in the depths. As we ponder the impact of camouflage and mimicry on the survival of these extraordinary species, we are reminded of the delicate balance that sustains the intricate ecosystems beneath the waves. Each adaptation speaks to the unwavering quest for survival in a realm where the stakes are high, and the shadows hold both danger and opportunity. In the depths of the ocean, where sunlight is but a distant memory, the relationships between predator and prey are defined by an intricate dance of visibility and concealment. The sheer variety of camouflage and mimicry tactics reveals not only the creativity of evolution, but also the relentless pursuit of survival in a world filled with constant threats. Imagine a delicate balance where the very colors and shapes of life can mean the difference between safety and vulnerability. Deep-sea creatures exhibit remarkable adaptations that challenge our understanding of survival strategies. Among these, the barrel-eye fish stands out with its translucent head and upward-facing eyes encased in a fluid-filled dome. This unique feature allows it to observe both the faintest glimmers of bioluminescence above and the silhouettes of prey below. By remaining nearly invisible against the ocean's murky backdrop, it can ambush unsuspecting prey with an enigmatic grace. Who would have thought that such a peculiar form could be a master of stealth? Consider also the mimicry displayed by the flatfish, which can alter its coloration and texture to mimic the ocean floor. This capability allows it to blend in seamlessly, evading predators while it lies in wait for its own meals. Flatfish possess the remarkable ability to change not just their color, but also their body shape, flattening themselves against the substrate. This ability highlights how species utilize their surroundings to enhance their survival, a theme that resonates throughout the deep ocean. In the realm of mimicry, the similarities between species can be astonishing. The harmless blenny fish mimics the appearance of a more dangerous species, the lionfish. By adopting the lionfish's distinctive stripes and spines, the blenny deters potential predators who instinctively associate those traits with danger. This strategy of deception serves as a testament to the complex social dynamics that exist even in the depths of the ocean. Imagine the cleverness required to not only adapt physically, but to embody the essence of another creature entirely. As we explore these survival tactics, it becomes evident that the delicate balance between predator and prey is constantly shifting. When a species successfully employs camouflage or mimicry, it can lead to cascading effects throughout its ecosystem. The increase in one species' survival rate may inadvertently place pressure on others, creating a ripple effect that alters food webs and population dynamics. The vibrant world of coral reefs is another stunning example of how these adaptations manifest in diverse forms. Here, the clownfish has found refuge among the anemones, which provide protection from predators. In return, the clownfish offers nutrients to the anemones through its waste and helps keep them clean. This mutualistic relationship illustrates how camouflage and mimicry can extend beyond mere survival. They can foster intricate partnerships that enhance the resilience of entire ecosystems. The vibrant colors of the reef also serve a purpose in attracting mates, a phenomenon that can complicate the survival strategies of its inhabitants. The colorful displays of the parrotfish, for example, not only help it evade predators, but also play a crucial role in courtship. The interplay of attraction and evasion in this environment is a reminder of the multifaceted nature of survival in the deep. How do organisms balance these competing needs? Their adaptations often reflect a complex interplay of evolutionary pressures that shape their very existence. In the pelagic zone, where light filters through the surface, we find creatures like the lanternfish, which rely on their bioluminescent capabilities to communicate and navigate. These small fish utilize a unique form of camouflage known as counterillumination, where they emit light from their undersides to match the brightness of the ocean's surface above. This adaptation allows them to blend seamlessly with the surrounding water, evading predators lurking beneath. The lanternfish exemplifies how light can serve as both a tool for survival and a source of danger. As fascinating as these adaptations are, they also pose questions about the future of these species in a changing world. What happens when environmental conditions shift and familiar patterns of camouflage and mimicry no longer suffice? Climate change and ocean acidification threaten the delicate balance of these ecosystems, forcing creatures to adapt at an unprecedented pace. The very tactics that have ensured their survival for generations may be tested in ways we cannot yet foresee. In the deep ocean, where mystery reigns and survival is a daily challenge, the stories of these creatures remind us of the resilience of life. Each adaptation tells a tale of evolution, a narrative woven through the ages as species learn to navigate the complexities of their environment. As we ponder these remarkable strategies, we are invited to reflect on the interconnectedness of all life forms and how their fates are intertwined in the vast tapestry of the ocean. The beauty of the deep lies not just in its wonders, but in the lessons it holds for us all. Chapter 5: Extremophiles, Life in Harsh Conditions. In the realm of life as we understand it, extremophiles emerge as remarkable entities, defying our conventional notions of survival. These extraordinary organisms thrive in conditions that would be deemed hostile, even lethal, to most forms of life. Imagine environments so extreme that the air itself burns, or waters so acidic that they dissolve metal. Yet, within these harsh realms, extremophiles flourish, showcasing nature's resilience and ingenuity. They are tiny, yet their influence is vast, revealing the adaptability of life and the possibilities that lie beyond our ordinary experiences. Extremophiles can be defined as organisms that not only survive but thrive in conditions that would challenge the very essence of life itself. They exist in environments characterized by extreme temperatures, pH levels, salinity, and pressure. For example, consider the thermophiles, which inhabit hot springs and hydrothermal vents where temperatures can soar well above the boiling point of water. These organisms possess unique proteins and enzymes that remain stable and functional in such heat. As biochemist Thomas C. Montagnier once noted, life exists in the most extreme conditions, and we must learn to understand it. In the deep ocean, where the light never reaches, extremophiles play a vital role in sustaining the ecosystem. Among them are the psychrophiles, thriving in frigid waters near freezing. Imagine the depths of the ocean, where icy tendrils of water envelop the darkened landscape. Here, psychrophiles have developed adaptations that allow them to maintain fluid membranes, ensuring their cellular machinery functions even under icy pressures. One such organism, Psychrobacter cryohalolentes, is a testament to life's versatility, exhibiting metabolic pathways that enable it to extract energy from organic compounds in these cold, nutrient-scarce environments. As we descend further into the abyss, we encounter the deep-sea hydrothermal vents, where the Earth's crust gives way to a world of boiling mineral-rich waters, spewing forth clouds of black smoke. Here, life thrives in darkness, nourished by the chemical compounds released from the Earth's bowels. The extremophiles found in these vent communities, such as tube worms and certain types of archaea, rely on chemosynthesis rather than photosynthesis. Imagine the vibrant ecosystems clustered around these vents, where tube worms host symbiotic bacteria that convert hydrogen sulfide into organic matter. This unique relationship underscores the intricate balance of life, revealing that in the absence of sunlight, life can harness energy from the very building blocks of the planet itself. The biological processes that support life in these extreme environments are as fascinating as the organisms themselves. The enzymes produced by extremophiles are of particular interest to scientists, as they possess unique properties that can be harnessed for various applications, from industrial processes to medical advancements. These heat-stable enzymes, known as extremozymes, are prized for their ability to catalyze reactions under conditions that would denature ordinary enzymes. Imagine a world where these extremozymes are used to enhance biofuel production or to develop new pharmaceuticals that can withstand extreme conditions within the human body. Furthermore, extremophiles are not just fascinating from a biological perspective, they hold profound implications for the field of astrobiology. The study of these resilient organisms offers insights into the potential for life beyond Earth. If life can thrive in the harshest conditions on our planet, what could be lurking in the depths of icy moons like Europa or the sulfuric atmospheres of Venus? The environments of these celestial bodies may mimic the conditions extremophiles call home, igniting hope that we are not alone in the cosmos. Renowned astrobiologist Carl Sagan once mused, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." This profound connection between life on Earth and the universe invites us to ponder the possibilities of life elsewhere. The existence of extremophiles suggests that life may be more adaptable than we ever imagined, capable of enduring in the most unforgiving of places. As we venture further into the mysteries of extremophiles, we are reminded that life, in all its forms, is intricately woven into the fabric of our universe. These resilient organisms challenge our understanding of biology and push the boundaries of what we consider possible. They beckon us to explore the unseen corners of our world and beyond, revealing that even in the harshest conditions, life finds a way to thrive. As we explore the biological processes that sustain extremophiles, we uncover a fascinating interplay of chemical reactions that enable life in the most inhospitable conditions. The enzymes produced by these resilient organisms are not just tools for survival. They represent an extraordinary evolutionary adaptation. For instance, the proteins found in thermophiles are often hyperthermophilic, meaning they retain their functionality at temperatures that would denature typical proteins. This stability is essential for their survival in environments such as hydrothermal vents, where temperatures can reach staggering levels. Consider the enzymes extracted from Pyrococcus furiosus, a species of archaea known for thriving in extreme heat. These enzymes have been harnessed in biotechnology for applications such as polymerase chain reactions, a technique pivotal in genetic research. Imagine the potential of these extraordinary molecules, allowing scientists to unlock the secrets of DNA in ways that were previously unimaginable. This synergy between extremophiles and scientific advancement illustrates how life can inspire innovation. The adaptations of extremophiles extend beyond their enzymes. They employ various metabolic pathways that enable them to extract energy from their surroundings in ways that challenge our understanding of energy sources. Some extremophiles utilize sulfur compounds, while others harness the energy of hydrogen gas emitted from geological reactions. In the deep-sea hydrothermal vent communities, for example, chemosynthetic bacteria convert carbon dioxide and hydrogen sulfide into organic matter, forming the foundation of an entire ecosystem. This process, known as chemosynthesis, allows life to flourish in complete darkness, sustained by the minerals and chemicals spewed forth from the Earth's crust. In this hidden world, life exists in forms we might never have anticipated. Imagine a landscape where giant tube worms, some reaching lengths of several feet, thrive without sunlight. Their bodies host symbiotic bacteria that perform chemosynthesis, converting the vent's toxic emissions into sustenance. This remarkable collaboration between species showcases the intricate relationships that define life in extreme environments. It raises intriguing questions. How many more partnerships like this exist in the depths of our oceans? What can these relationships teach us about the interconnectedness of life? The significance of extremophiles extends far beyond their immediate environments. They serve as a beacon for astrobiology and our quest to understand life beyond Earth. The potential for life on other celestial bodies hinges on the adaptability we observe in extremophiles. For instance, the icy surfaces of moons like Europa, which are believed to harbor vast oceans beneath their frozen crusts, may provide habitats for extremophilic life forms. Scientists speculate that if life can endure the harsh conditions of our planet, it may also thrive in similar environments elsewhere in the universe. The notion that life could exist on other planets ignites our imagination. Consider the sulfuric acid clouds of Venus, where researchers ponder the possibility of microbial life surviving in the upper atmosphere. The extreme pressure and temperature on Venus may seem insurmountable, yet extremophiles challenge our perceptions of what constitutes a habitable environment. As astrobiologist Chris McKay once stated, life is a way for the universe to know itself. This perspective invites us to reflect on the myriad forms that life might take across the cosmos. The search for extraterrestrial life is not merely an academic exercise. It is a journey that speaks to our fundamental curiosity and desire for connection. As we study extremophiles, we gain insights into the resilience of life and the conditions that support it. Each discovery adds a new thread to the narrative of existence, weaving a more intricate understanding of what it means to be alive in this vast universe. The implications of extremophile research stretch into practical realms as well. Their unique metabolic processes could offer solutions to pressing challenges on Earth, such as waste management and biofuel production. Imagine harnessing the power of extremophiles to break down pollutants in contaminated environments or to create sustainable energy sources. The possibilities are as boundless as the oceans themselves, waiting for us to explore. As we delve into the extraordinary world of extremophiles, we discover that these seemingly simple organisms are a testament to life's tenacity. They compel us to reconsider the boundaries of life and the environments in which it can thrive. The deep-sea ecosystems, with their vibrant communities and astonishing adaptations, remind us that life is not merely a product of ideal conditions, but rather a dynamic force that can flourish in even the most extreme circumstances. In this ongoing exploration, we are beckoned to witness the stories of extremophiles, to understand their significance, and to embrace the mysteries that lie ahead. In the symphony of life, they play a crucial role, orchestrating a melody of resilience and adaptation that resonates beyond the confines of our planet. As we seek to understand the universe, we find ourselves drawn closer to the extraordinary potential of life, wherever it may exist. In the embrace of these extreme environments, extremophiles reveal a treasure trove of biochemical ingenuity. Their metabolic processes often diverge significantly from those of more familiar organisms, showcasing life's remarkable capacity to adapt to its surroundings. For instance, certain halophiles thrive in environments with such high salt concentrations that few other life forms can endure. These organisms have evolved specialized proteins that maintain their structural integrity and functionality, allowing them to harness energy from the very salt that would be toxic to most. Imagine the vibrant colors of salt flats, shimmering under the sun, where life clings tenaciously in the form of these resilient microorganisms. The adaptations of extremophiles also extend to their cellular membranes. In extreme heat, pressure, or salinity, the fatty acids that compose their membranes become crucial. Some halophiles, for example, utilize unique lipids that prevent their membranes from collapsing in high-salt environments, while thermophiles stabilize their membranes with saturated fatty acids that withstand intense temperatures. This biochemical creativity suggests that life, like a skilled artist, can manipulate its canvas to suit the extremes of its habitat. As we think about these adaptations, we may wonder about the implications for biotechnology. The enzymes derived from extremophiles, such as those from the hyperthermophilic archaeon Thermus aquaticus, have revolutionized molecular biology. The enzyme Taq polymerase, crucial for the polymerase chain reaction, allows for the amplification of DNA sequences in laboratory settings. This powerful technique has paved the way for advancements in genetic research, forensic science, and even medical diagnostics. Consider how the study of these organisms opens doors to innovations that can significantly impact our lives. Moreover, extremophiles serve as a bridge to understanding life's potential beyond our planet. The principles that govern their existence provide a framework for scientists exploring the conditions necessary for life elsewhere in the universe. The icy moons of Europa and Enceladus, for instance, are intriguing targets in the search for extraterrestrial life. Beneath their frozen surfaces, vast oceans may harbor extremophiles similar to those found in our own deep seas. The exploration of these celestial bodies ignites our imagination, prompting us to ask, could life exist in the dark, frigid waters of these distant worlds, drawing energy from chemical processes just as the organisms around hydrothermal vents do? The significance of extremophiles for astrobiology cannot be overstated. Their existence challenges the traditional definitions of habitability and compels us to rethink where and how life might arise. As we consider the hostile environments of other planets and moons, we begin to appreciate the vastness of possibilities. The resilience demonstrated by extremophiles on Earth suggests that life may be more widespread than we once believed, lurking in the shadows of the cosmos, waiting for discovery. As we delve deeper into the implications of extremophiles, we find ourselves contemplating the ethical dimensions of our exploration. What responsibilities do we carry as we seek to uncover life beyond our planet? The potential discovery of extraterrestrial life raises questions about how we will interact with these organisms and the ecosystems they inhabit. Will we approach them with reverence or with a desire to exploit? The lessons learned from extremophiles on Earth can guide our actions, encouraging us to foster a sense of stewardship toward all forms of life, whether familiar or alien. In the grand narrative of existence, extremophiles are not merely oddities. They are pioneers of survival, illuminating the path to understanding life in all its forms. Their unique adaptations inspire curiosity and wonder, urging us to explore the depths of our own planet and beyond. Each discovery adds layers to our comprehension of life's potential, weaving a rich tapestry of resilience and adaptation that transcends the boundaries of Earth. As we journey through the extraordinary world of extremophiles, we are reminded that life is an unyielding force. Their stories challenge us to think broadly about our own existence and the myriad forms it may take in the universe. The quest for knowledge continues, driven by the understanding that in the most extreme conditions, life persists, flourishing against all odds. The secrets of extremophiles beckon, inviting us to explore the uncharted territories of our world and beyond, where the possibilities of life are as deep and profound as the ocean itself. Chapter 6: Reproductive Strategies, Adapting to Isolation. In the profound depths of the ocean, where darkness reigns and the pressure mounts beyond our comprehension, life faces unique reproductive challenges. The deep sea, with its vastness and isolation, presents a formidable environment for species striving to ensure the continuation of their kind. Imagine the difficulty of finding a mate in a realm where distances stretch endlessly and the sheer volume of water dilutes the signals of courtship. In this hidden world, reproductive strategies have evolved in extraordinary ways, shaped by the constraints and opportunities of their surroundings. One prominent strategy employed by many deep-sea organisms is broadcast spawning. This method involves releasing vast quantities of eggs and sperm into the water column simultaneously, allowing fertilization to occur in the open ocean. Picture the spectacle of a coral reef bursting into a cloud of colors as millions of gametes are released into the water, a synchronized event timed with lunar cycles. This phenomenon, known to occur in various marine species, exemplifies the power of cooperation among individuals, even in a seemingly solitary world. The sheer volume of gametes increases the chances of successful fertilization, compensating for the challenges posed by the expansive environment. Yet this strategy is not without its drawbacks. The ephemeral nature of the gametes means that many may never find each other in the vastness of the ocean. In contrast, some deep-sea species have adapted through more intimate methods of reproduction. Take, for instance, the anglerfish, a creature whose peculiar mating practices reflect the challenges of life in isolation. The male anglerfish, significantly smaller than the female, seeks out a mate by detecting chemical signals in the water. Once he finds her, he latches onto her side, fusing their bodies together. This fusion allows the male to receive nutrients directly from the female while providing her with a constant source of sperm. This adaptation, while unconventional, enables both partners to overcome the difficulties of finding one another in an environment where encounters are rare. Parental care varies significantly among deep-sea species, with some providing extensive nurturing while others adopt a more hands-off approach. For example, the male seahorse has become famous for its role in nurturing offspring, as it carries fertilized eggs in a specialized pouch until they are ready to be born. This remarkable adaptation allows for a higher survival rate of the young in the perilous depths, where predators abound and resources are limited. Imagine the sight of tiny seahorse fry emerging from their father's pouch, each a miniature replica of the adult, ready to face the challenges of their world. In contrast, many other deep-sea species exhibit little to no parental investment. The vast majority of fish in the deep ocean release their eggs into the depths, leaving them to drift and fend for themselves. This strategy reflects a fundamental trade-off. By producing a large number of offspring, these species increase the odds that at least some will survive. The ocean is a cruel teacher, and many young are lost to predators or inhospitable conditions. Yet, for those that do survive, the rewards can be bountiful. The impact of these reproductive adaptations on population dynamics is profound. In the deep sea, where resources are scarce and environments are harsh, strategies that enhance reproductive success can determine the fate of entire populations. Those species that excel at fertilization through broadcast spawning may experience population booms during favorable conditions, while others that invest heavily in parental care may see their numbers dwindle if conditions become unfavorable. Consider the fascinating case of the giant squid, a creature that embodies the mysteries of the deep. It is thought to engage in a unique reproductive strategy, wherein females may spawn only once in their lifetime, investing all their energy into producing a massive clutch of eggs. This singular focus on reproduction, combined with the perilous nature of their environment, ensures that each spawning event is critical for the continuation of the species. As we ponder the intricacies of these reproductive strategies, we are reminded of the delicate balance that exists in the deep ocean. The adaptations that species develop are not merely responses to their surroundings. They are reflections of evolutionary pressures that shape their very existence. Each reproductive strategy, whether it be the vast releases of eggs or the tender care of parents, plays a role in the survival of species within this vast, unforgiving habitat. Moreover, the isolation inherent in the deep sea creates a unique evolutionary pressure, fostering diversity among reproductive strategies. Species that inhabit isolated trenches or canyons may develop distinct adaptations that set them apart from their relatives in shallower waters. This phenomenon of speciation through isolation highlights the resilience of life, showcasing the remarkable ways in which organisms adapt to their environments. In the grand tapestry of life beneath the waves, every reproductive strategy contributes to an intricate web of relationships, each one vital to the ecosystem. The dynamics of reproduction not only influence the fate of individual species, but also affect the broader community of life in the deep ocean. As we explore these depths, we gain insight into the myriad ways life has found to thrive, even in the most challenging of circumstances. Imagine the wonders that await discovery in this hidden realm. The deep ocean is a testament to nature's ingenuity, a place where life persists against the odds. In this world of silence and darkness, the strategies of reproduction reveal a story of resilience and adaptation, inviting us to contemplate the mysteries that lie beneath the waves. As we continue to uncover the secrets of the deep, we are reminded of the delicate balance that sustains life in this vast, enigmatic habitat. In the deep ocean, where the dance of life unfolds in shadows, reproductive strategies not only define species, but also determine their fate in an ever-changing environment. As we explore these adaptations, we find that the deep sea's isolation has not stifled creativity. Instead, it has sparked a remarkable diversity of reproductive tactics that reflect the complex interplay of evolutionary pressures. Take, for instance, the fascinating world of deep-sea corals. Unlike their shallow-water relatives, which often rely on symbiotic relationships with photosynthetic algae, deep-sea corals thrive in complete darkness. These corals have evolved a unique strategy for reproduction, often employing a method known as brooding. In this process, corals retain fertilized eggs within their tissues, nurturing them until they develop into planulae, tiny larvae that will eventually settle on suitable substrates. This strategy not only enhances the survival rate of the young, but also allows corals to adapt to their specific local conditions, ensuring that their offspring are well suited to the environment they will inhabit. Imagine the scene as these delicate creatures release their larvae into the darkness, a cloud of potential drifting into the void. This nurturing approach stands in stark contrast to the broadcast spawning of other species, highlighting the myriad ways life can persist in the depths. Another intriguing adaptation can be found in the reproductive behaviors of cephalopods, such as the octopus and the cuttlefish. Many species exhibit a level of parental investment that is uncommon in the animal kingdom. Female octopuses, for example, often lay thousands of eggs, carefully tending to them until they hatch. During this time, the mother typically refrains from feeding, dedicating her life to ensuring the survival of her offspring. This sacrifice is a poignant reminder of the lengths to which parents will go for the next generation, echoing themes of care and nurturing that resonate through various species in the deep. Yet, in this world of extremes, the balance between nurturing and survival is delicate. The harsh realities of the deep sea mean that not all offspring will survive, and many species have adapted by producing an abundance of eggs to offset the losses. This strategy is particularly evident in species like the deep-sea jellyfish, which can release millions of eggs into the water, relying on sheer numbers to ensure that some will reach maturity. The implications of these reproductive strategies ripple through the community of life in the deep ocean. When conditions are favorable, species employing broadcast spawning may thrive, leading to sudden population booms that alter the dynamics of the ecosystem. Conversely, species that invest heavily in parental care may struggle when conditions become unfavorable, demonstrating the fragility of these relationships in the face of environmental change. This interplay of reproductive strategies and population dynamics can be observed in the behaviors of deep-sea fish as well. Many species have evolved to be highly opportunistic, exploiting seasonal upwellings of nutrients that bring life to the dark depths. During these events, the timing of reproduction becomes critical. Species that can synchronize their spawning with the arrival of food sources can enhance the survival chances of their offspring, illustrating a profound connection between environmental conditions and reproductive success. Consider the remarkable adaptation of the lanternfish, one of the most abundant fish in the ocean. This small creature plays an essential role in the deep-sea food web, and its reproductive strategy is intricately tied to its bioluminescent capabilities. Lanternfish can emit light to attract mates and may use this ability to communicate during the spawning season. Their reproductive success is intricately linked to the availability of prey and the rhythms of the ocean, showcasing the interconnectedness of life in this vast environment. As we ponder these diverse reproductive strategies, we are reminded of the extraordinary resilience of life in the deep sea. Each species, whether it is a solitary anglerfish or a bustling community of coral, has adapted in ways that reflect their unique circumstances. The isolation of the deep ocean has fostered a remarkable array of reproductive tactics, illustrating the innovative ways in which life can flourish, even in the most inhospitable conditions. The impact of these adaptations extends beyond individual species, influencing the broader marine ecosystem. The interplay of various reproductive strategies creates a dynamic web of relationships that underscores the interconnectedness of life beneath the waves. Each spawning event, every nurturing parent, plays a crucial role in maintaining the balance of this hidden world. As we navigate through these depths, we find ourselves in awe of the myriad ways in which life persists against the odds. The reproductive strategies of deep-sea creatures illuminate the beauty of adaptation, offering a glimpse into the resilience that defines life in the ocean. In this realm of darkness, where survival is a constant struggle, the stories of these organisms invite us to reflect on the delicate balance that sustains them and the intricate dance of life that unfolds in the shadows. Imagine the wonders that await in these depths, where the mysteries of reproduction intertwine with the very essence of existence. The deep sea, in all its isolation and beauty, reveals a narrative of resilience and adaptability, urging us to contemplate the extraordinary strategies that have allowed life to thrive in this enigmatic habitat. Each whisper of the current carries with it the echoes of countless generations, a testament to the unyielding spirit of life beneath the waves. Chapter 7: Sensory Adaptations, Navigating the Darkness. As we immerse ourselves deeper into the shadowy embrace of the ocean, we encounter realms where light cannot penetrate, and the sensory challenges become profound. The deep-sea environment, an abyss of solitude, demands that its inhabitants develop extraordinary adaptations to perceive and interact with their surroundings. Imagine a world where sight is rendered nearly useless, where darkness reigns, and the only clues to existence come through the senses of touch, smell, and even the enigmatic ability to detect electrical signals. In this perpetual twilight, vision plays an intricate role for creatures that dwell in the depths. Many organisms have evolved large, sensitive eyes, perfectly designed to capture the faintest glimmers of bioluminescence produced by their neighbors or potential prey. These adaptations allow them to see in shades of blue and green, colors that travel best through water. Picture the deep-sea anglerfish, with its bioluminescent lure shimmering in the darkness, drawing in curious prey. Its eyes, adapted to the low-light conditions, are finely tuned to detect even the slightest movements in the surrounding water. Yet, not all creatures in the deep rely solely on vision. The challenges of navigating through an environment devoid of light have led many to hone their sense of smell. The olfactory capabilities of deep-sea inhabitants are often surprisingly acute. Imagine a vast ocean where the scent of food or the pheromones of a mate can travel long distances, guiding creatures through the dark expanse. The deep-sea squid, for example, utilizes its keen sense of smell to locate prey from afar, sensing the chemical signatures left behind by potential meals. This ability to detect scents in the water is a critical adaptation, enhancing survival in an environment where visibility is compromised and food sources are scarce. The sense of touch also plays a vital role in the lives of deep-sea creatures. Many species have developed specialized appendages that allow them to explore their surroundings, feel the contours of the ocean floor, and interact with other organisms. Imagine a deep-sea octopus as it glides through the dark waters, using its sensitive suckers to explore crevices and search for hidden prey. These suckers are equipped with thousands of sensory receptors, allowing the octopus not only to grasp, but also to feel and taste its surroundings. This tactile exploration is essential for foraging in an environment where sight may offer little guidance. Amidst these adaptations lies the remarkable phenomenon of electroreception. Some deep-sea species possess specialized organs that enable them to detect electrical fields generated by the movements of other organisms. Imagine the predatory prowess of the electric eel, capable of sensing the faintest electrical impulses emitted by its prey. This ability not only aids in hunting, but also assists in navigation through the murky waters, revealing the presence of objects and fellow creatures that would otherwise remain hidden in the shadows. Electroreception expands the sensory toolkit available to deep-sea dwellers. It allows them to communicate with one another, navigate through the darkness, and hunt effectively in an environment where traditional senses may falter. This adaptation is exemplified by the cartilaginous fish, such as sharks and rays, which are equipped with specialized sensory organs known as ampullae of Lorenzini. These organs allow them to detect minute electrical changes in the water, guiding them in the pursuit of prey and helping them to navigate the often turbulent waters of the deep. As we explore these sensory adaptations further, we begin to understand their profound impact on behavior and survival. The ability to see, smell, touch, and sense electrical impulses shapes not only how deep-sea creatures hunt, but also how they interact with one another. Picture a schooling fish, its movements synchronized as it navigates through the dark waters. The collective awareness of the group, heightened by their acute senses, provides safety in numbers, facilitating their survival against predators lurking in the shadows. The role of sensory adaptations in mating behaviors is equally compelling. In the depths, where the chances of encountering a mate can be slim, these adaptations become critical for reproductive success. Imagine a male deep-sea anglerfish, its bioluminescent lure signaling to potential partners in the vast emptiness. The ability to detect chemical signals in the water, combined with visual cues, ensures that these creatures can locate one another amidst the darkness, fostering the continuation of their species. In this world of sensory wonders, we find a rich tapestry of life that thrives against the odds. The adaptations for vision, smell, touch, and electroreception are not just survival mechanisms. They are essential tools that enable creatures to navigate the complexities of their environment. As we reflect on the resilience of these deep-sea inhabitants, we marvel at the ingenuity of evolution, which has sculpted these remarkable adaptations over countless generations. Each adaptation tells a story of survival, of the relentless pursuit of life in an environment where light fades and the pressures mount. The deep sea, with its sensory challenges and remarkable solutions, continues to captivate our imagination, inviting us to ponder the mysteries that lie beneath the waves. What other secrets does this vast expanse hold, waiting to be uncovered by those who dare to delve into its depths? As we drift further into the depths, we uncover the myriad ways in which these adaptations guide the behavior and survival strategies of deep-sea life. The ability to detect and interpret environmental signals is woven into the very fabric of existence in this dark, mysterious realm. Sensory adaptations are not merely functional. They shape the intricate behaviors that define life in the abyss. Consider the role of smell in predator-prey interactions. The deep-sea environment often presents a buffet of opportunities, yet locating food can be a daunting task. For many species, the ability to detect chemical cues in the water is a matter of life and death. Imagine a deep-sea scavenger, like the opportunistic amphipod, utilizing its acute sense of smell to locate carrion drifting down from the surface. These creatures can detect the scent of decomposing organic matter from considerable distances, guiding them to vital food sources in an otherwise barren landscape. The olfactory signals act as beacons, illuminating pathways to sustenance in the vast, dark ocean. Furthermore, communication among deep-sea residents can be equally fascinating and complex. Chemical signals often play a pivotal role in mating rituals and social interactions. Picture a scenario where a female deep-sea fish releases pheromones into the water, signaling her readiness to mate. Males, equipped with a finely tuned sense of smell, pick up these signals, navigating through the dark waters toward their potential partner. This chemical dialogue transcends the barriers of light and distance, ensuring that reproduction can occur even in the most isolated of environments. The sense of touch, too, extends beyond simple exploration. Many deep-sea species utilize their tactile abilities in social interactions. Imagine a group of fish gently brushing against one another, exchanging information about their surroundings or signaling for safety. The sensitive skin and specialized sensory structures of these creatures allow them to perceive subtle changes in their environment, fostering connections that enhance their survival. Each touch conveys a wealth of information, building a community in the depths that would otherwise seem desolate. In addition to these adaptations, the phenomenon of electroreception stands out as a remarkable evolutionary feat. Imagine a predator lurking in the shadows, its senses alert to the slightest movements of potential prey. Equipped with specialized organs, such as electroreceptors, creatures like the hammerhead shark can detect the electric fields produced by the muscle contractions of nearby fish. This ability is not just a hunting strategy. It represents a profound connection to the natural world, allowing these predators to thrive in an environment where visual cues are limited. The interplay of these sensory adaptations shapes behavior and survival in ways that reveal the intricate web of life beneath the waves. As creatures navigate their surroundings, they must also contend with the ever-present threat of predation. The behavioral adaptations that arise from sensory capabilities are often a dance of instinct and learned behavior. Imagine a small fish darting through the water, employing rapid movements to evade a larger predator. The ability to sense vibrations in the water and detect changes in pressure allows these fish to react swiftly, enhancing their chances of survival. In the realm of deep-sea communication, bioluminescence adds another layer of complexity. While we often think of it as a tool for attracting prey, it also serves as a mechanism for social interaction. Picture a gathering of bioluminescent organisms, their lights flickering in a synchronized rhythm. These displays can signify warnings, attract mates, or even facilitate group cohesion. The language of light transforms the darkness into a canvas of expression, where creatures communicate their intentions and emotions through bursts of color and illumination. As we reflect on these adaptations, we cannot overlook the remarkable examples set by pioneers in deep-sea exploration. Scientists like Sylvia Earle have dedicated their lives to uncovering the mysteries of the ocean, advocating for the protection of these fragile ecosystems. Earle once expressed, "We are the most intelligent species on the planet, yet we know so little about the sea." Her words resonate as a reminder of the vast unknowns that still await discovery in the depths. Each expedition reveals new insights into the sensory adaptations of marine life, illuminating the intricate connections that bind the inhabitants of the deep. The impact of sensory adaptations on behavior extends beyond individual survival to encompass the dynamics of entire ecosystems. In the vast expanses of the ocean, species rely on one another, forming intricate relationships that sustain life. Consider the role of symbiosis, where different organisms coexist and benefit from each other's presence. The delicate balance of these interactions is often influenced by the sensory capabilities of the species involved, highlighting the interconnectedness of life in the deep. In an environment where survival often hinges on the ability to sense and respond to a myriad of stimuli, the adaptations we have explored become a testament to the resilience of life. The deep sea is more than a realm of darkness. It is a vibrant world, pulsating with the energy of creatures that have mastered their surroundings. Each sensory adaptation is a thread in the rich narrative of existence, weaving together stories of survival, interaction, and the relentless pursuit of life amidst the shadows. As we ponder the incredible adaptations that have emerged in the depths, we find ourselves drawn to the question of how these traits might evolve further. What new abilities may arise as organisms continue to adapt to the ever-changing conditions of their environment? The deep sea, with its unending mysteries, invites us to imagine the future of life in this alien landscape, where sensory adaptations will undoubtedly continue to evolve, revealing even more of nature's ingenuity. The delicate balance of life in the deep sea is not solely dictated by the physical adaptations of its inhabitants, but also by their behavioral strategies, intricately woven into the fabric of their sensory capabilities. As we observe these remarkable creatures, we find that their adaptations are manifestations of an ancient wisdom, honed over countless generations to thrive in a realm where darkness and pressure are constants. Consider the role of communication in this dark expanse. The ability to convey information through chemical signals or bioluminescence is vital for maintaining social structures amongst species. Imagine a deep-sea shrimp that emits specific pheromones to alert its companions of potential dangers lurking nearby. This chemical communication, often imperceptible to human senses, becomes a lifeline, a way for these creatures to navigate their perilous world. Such interactions extend beyond mere survival. They create a community amidst the vast emptiness, enhancing the chances of lasting existence in a world where isolation can be a formidable foe. The profound depths also reveal how sensory adaptations can influence feeding behaviors. Picture a group of deep-sea fish, their bodies shimmering with bioluminescent patterns, signaling to one another as they form hunting packs to pursue prey. This cooperative hunting strategy demonstrates the effectiveness of using combined sensory abilities. By working together and sharing information, these fish can increase their success rate, showcasing the power of collaboration in an environment where food is often scarce and elusive. Moreover, the intricate relationship between predator and prey is a dance of adaptation. The deep-sea lanternfish, a staple in the diet of larger predators, employs bioluminescence not only to attract mates, but also to evade capture. It can control the intensity and pattern of its glow, creating a momentary distraction that allows it to escape from a predator's grasp. This interplay of light and dark emphasizes the adaptability inherent in the behaviors of these creatures, revealing how sensory adaptations have profound implications for survival in their shadowy world. In these depths, the phenomenon of mimicry also plays a critical role in survival strategies. Imagine a deep-sea fish that possesses the ability to replicate the bioluminescent patterns of its surroundings, allowing it to blend seamlessly into the dark water. This clever adaptation not only aids in evasion from predators, but also enhances its ability to ambush unsuspecting prey. Through mimicry, creatures can navigate the complexities of their environment, showcasing the innovative strategies life employs to endure. The journey into the deep sea also unveils the intricate relationship between sensory adaptations and reproductive strategies. As we have explored, the isolation of the deep ocean presents unique challenges for finding mates. Yet, the sensory capabilities of deep-sea organisms facilitate remarkable courtship displays. Picture a male fish that flashes its bioluminescent patterns in intricate displays, catching the attention of potential mates. This visual spectacle, amplified by the dark surroundings, serves as an invitation, a beacon in the vastness that speaks of vitality and readiness to reproduce. As we ponder these adaptations, the profound impact of sensory capabilities becomes evident in the broader ecological context. Each species, equipped with its unique sensory tools, contributes to a dynamic ecosystem where interdependence reigns. The scavengers, predators, and prey all play their part, creating a delicate balance that sustains life in the abyss. This interconnectedness reminds us that in the depths of the ocean, survival is not just a solitary endeavor. It is a symphony of interactions, each note resonating with the others in harmony. The adaptations we have explored thus far invite us to consider the future of these remarkable creatures. As environmental changes ripple through the ocean, how will these adaptations evolve? Will the deep-sea inhabitants continue to refine their sensory capabilities in response to shifting conditions? The resilience of life is often tested, and the deep sea, with its myriad challenges, serves as a canvas upon which evolution continues to paint its intricate designs. In this hidden world, where darkness reigns and pressure mounts, the adaptations of deep-sea life not only illuminate their survival strategies, but also reflect the broader narrative of life on Earth. Each creature, with its unique sensory toolkit, embodies the story of resilience and adaptation, navigating the complexities of existence in the deep. As we draw closer to understanding these adaptations, we find ourselves captivated by the wonders of life beneath the waves, ever curious about the secrets still waiting to be discovered in the depths of our oceans. Chapter 8: Gigantism and Miniaturization, Size Extremes. In the dim, uncharted depths of the ocean, where the light of the sun is but a distant memory, a fascinating phenomenon unfolds. Here, in the cool embrace of the abyss, we witness two extreme adaptations to life: gigantism and miniaturization. These contrasting strategies, seemingly contradictory, reveal the complex interplay of evolutionary forces that shape the organisms inhabiting this profound environment. Let us first immerse ourselves in the world of deep-sea gigantism. Imagine an ocean where creatures grow to sizes that challenge the imagination. The giant squid, a legendary inhabitant of these depths, can stretch nearly to the length of a school bus, its tentacles gracefully undulating in the dark waters. This phenomenon of increased size in deep-sea organisms, known as deep-sea gigantism, raises intriguing questions. What drives these creatures to grow so large in an environment characterized by extreme conditions? One leading theory posits that the scarcity of food plays a crucial role. In the deep sea, where nutrients are often limited, larger body sizes can be advantageous. A bigger organism may require less energy relative to its size, allowing it to survive on fewer resources. The colossal squid, for example, preys on fish and other cephalopods, using its size and strength to overpower its meals. In this realm of giants, size can also serve as a defensive mechanism. Larger creatures are often less vulnerable to predation, allowing them to thrive in a world where danger lurks in every shadow. Among the giants of the deep, the basking shark emerges as a gentle giant, gliding through the water with its mouth agape, filtering plankton from the ocean. This majestic creature, reaching lengths of up to 40 feet, plays a vital role in maintaining the balance of its ecosystem, contributing to the nutrient cycling that sustains countless marine species. The basking shark size is not merely a spectacle. It serves an ecological purpose, allowing it to harvest food efficiently in a vast, nutrient-sparse environment. In stark contrast to these giants, we find a captivating world of miniaturization. Imagine the delicate, almost ethereal beauty of tiny organisms that inhabit the deep. Among them are the enchanting amphipods, often no larger than a fingernail, yet they possess remarkable adaptations. Miniaturization in deep-sea organisms can provide distinct advantages. Smaller size often means a higher surface area to volume ratio, which can enhance gas exchange and nutrient absorption. These adaptations allow smaller creatures to thrive in an environment where resources are scarce. Consider the tiny marine snow, a continuous shower of organic particles that drifts down from the surface, providing sustenance for these miniature inhabitants. Their compact size enables them to take advantage of this nutrient flow, feeding on microscopic detritus that larger organisms may overlook. The world of deep-sea miniaturization reveals a hidden complexity, where even the smallest creatures play pivotal roles in the web of life. The evolutionary implications of size variations in the deep sea are profound. The adaptations of both giants and minuscule organisms speak to the resilience of life in the face of adversity. In a realm where pressure mounts and temperatures plunge, the ability to adapt is paramount. The existence of these size extremes prompts us to ponder: how do these adaptations reflect the broader themes of evolution and survival? As we explore further, we encounter the fascinating evolutionary strategies that have emerged in response to the unique challenges of the deep ocean. The phenomenon of size extremes is not merely an anomaly. It is a testament to the diverse pathways that evolution can take. The giants of the deep embody strength and resilience, while the small creatures represent adaptability and efficiency. Together, they illustrate the myriad ways life has forged its existence in the harshest of environments. Consider the impact of these size adaptations on the broader ecosystems of the deep sea. The interactions between giant and miniature organisms create a dynamic balance. Larger species often rely on smaller ones for food, while the abundant tiny creatures contribute to the nutrient cycling essential for the survival of larger predators. This intricate web of relationships highlights the interconnectedness of all life forms, no matter their size. As we delve into the depths of these considerations, we cannot overlook the remarkable discoveries made by scientists who have dedicated their lives to understanding these mysteries. Pioneering oceanographers and marine biologists have ventured into the abyss, using advanced technologies to explore these extreme environments. Their findings challenge our understanding of life, revealing the astonishing adaptability of organisms in the face of environmental pressures. Think of Dr. Charles Paxton, who has studied the patterns of gigantism and miniaturization in ocean life. He noted, "The immense diversity of sizes in the ocean showcases the creativity of evolution, reminding us that life can flourish in forms we might never expect." His insights capture the essence of our exploration into the extremes of size, revealing the beauty and complexity of life in the deep sea. As we reflect on the extraordinary adaptations of both giants and diminutive beings, we begin to appreciate the delicate balance of the deep-sea ecosystems. Although these creatures exist in a world fraught with challenges, they continue to thrive, each playing a vital role in their respective habitats. The coexistence of gigantic leviathans and minute marvels serves as a reminder of nature's boundless creativity and resilience. In contemplating the importance of these size extremes, we can envision the future of research and exploration in the deep ocean. As technology advances, we gain new tools to uncover the secrets of the abyss, to witness firsthand the breathtaking diversity of life that exists in these dark waters. The journey to understand the adaptation of organisms will continue to inspire future generations of scientists and curious minds alike. Imagine the possibilities that lie ahead as we strive to comprehend the mechanisms driving gigantism and miniaturization. The ocean remains a vast frontier, with innumerable species waiting to be discovered, each holding the key to understanding the evolutionary forces at play. This exploration offers not only insights into the past, but also a glimpse into the future of our planet and its precious ecosystems. As we venture deeper into this captivating world, we must remain mindful of the delicate balance that sustains life in the deep sea. The interplay between size extremes demonstrates the intricate dance of evolution, where giants and diminutive creatures alike contribute to the rich tapestry of marine life. The lessons learned from these adaptations can inform our understanding of resilience in the face of environmental change, guiding our stewardship of the oceans we hold dear. While we continue to uncover the mysteries of the deep, we must also reflect on our relationship with this vast body of water. The deep sea, a realm of size extremes, beckons us to explore, to learn, and ultimately to protect the delicate balance that sustains its inhabitants. Each journey into the depths enriches our understanding and deepens our connection to the natural world. In the embrace of the abyss, the giants and the small unite in an exquisite harmony, revealing the extraordinary potential of life in all its forms. The ocean's depths, with their secrets and wonders, remind us that size does not define significance. Whether colossal or minuscule, each creature plays its part in the grand narrative of existence, echoing the resilience of life itself. As we draw nearer to the conclusion of our exploration, the tales of deep-sea gigantism and miniaturization remind us of the boundless creativity inherent in nature. The extraordinary adaptations of these organisms serve as a testament to life's enduring spirit, urging us to continue our journey into the heart of the ocean and to cherish the wonders that await us below the waves. In the shadowy recesses of the deep sea, the phenomenon of miniaturization unfolds as an equally compelling counterpart to the giants of the abyss. This adaptation is not merely a reduction in size. It embodies a suite of evolutionary strategies that confer significant advantages in an environment where survival hinges on resourcefulness. Imagine the intricate ballet of life that occurs within the confines of a single drop of water, where minuscule organisms thrive, each playing a crucial role in the ecosystem. Among these diminutive beings, the tiny copepods stand out as remarkable examples. These microscopic crustaceans are often referred to as the insects of the sea. Their small size allows them to exploit a unique niche, feeding on phytoplankton and organic detritus that drifts through the water column. Their rapid reproductive rates and adaptability enable them to flourish in the nutrient-poor deep sea, where larger predators may struggle to survive. This dynamic relationship with their environment underscores the importance of miniaturization, illustrating how smaller creatures can efficiently utilize resources that might remain inaccessible to larger organisms. Consider the evolutionary implications of these adaptations. Miniature organisms often exhibit remarkable reproductive strategies, such as parthenogenesis, where females can produce offspring without fertilization. This trait can be particularly advantageous in isolated environments, allowing populations to expand even when finding mates is challenging. The ability to reproduce without male counterparts can ensure the survival of a species in the depths, where encounters between individuals are rare. In exploring the depth of miniaturization, we must also acknowledge the fascinating adaptations of deep-sea shrimp. Some species, like the amphipod known as the giant amphipod, can reach sizes much larger than their relatives, yet they still embody the characteristics of their smaller counterparts. Their streamlined bodies and specialized appendages make them agile hunters in the dark waters, where they scavenge for organic material. Imagine the grace with which these creatures navigate through a landscape of bioluminescent wonders, their small size providing them with the stealth necessary to evade larger predators while still efficiently capturing food. The ecological roles of these tiny organisms extend beyond mere survival. They serve as a vital link in the food web, providing sustenance for larger species, including fish and cephalopods. By converting the organic material available in the depths into energy, they facilitate nutrient cycling, ensuring that the larger inhabitants of the ocean can thrive. The intricate relationships between these sizes highlight the interconnectedness of the ecosystem, where each organism, regardless of its stature, plays a pivotal part. As we ponder the evolutionary pathways that lead to size extremes in the deep sea, we must also recognize the broader implications of these adaptations for our understanding of biodiversity. The diversity of life forms in these depths serves as a reminder of the resilience and versatility of nature. In the face of environmental challenges, both large and small organisms showcase the myriad ways life can adapt, survive, and flourish in seemingly inhospitable conditions. Reflecting on the discoveries made by scientists in this field, we can appreciate the illumination they provide into the evolutionary processes at play. Marine biologists and ecologists continue to unravel the mysteries of these unique adaptations, shedding light on how they reflect the delicate balance of ecosystems. The work of researchers like Dr. Sylvia Earle, who has dedicated her life to ocean exploration, reminds us of the wonders that await beneath the waves. The ocean is a place of great mystery and beauty, and we must strive to understand and protect its inhabitants, she once said, highlighting the importance of our stewardship over these vital ecosystems. As we delve deeper into the significance of size extremes in the ocean's depths, we see how the coexistence of giants and miniature beings illustrates the complex interplay of evolutionary forces. The adaptations seen in each group tell a story of survival, resilience, and the relentless pursuit of life. This narrative encourages us to consider the future of these ecosystems, especially as human activity increasingly impacts the deep sea. Imagine the challenges that lie ahead as we seek to protect the delicate balance of these environments. The rising temperatures, ocean acidification, and pollution threaten to disrupt the intricate relationships that have developed over millions of years. Understanding the dynamics of size extremes becomes even more crucial, as these adaptations may hold the key to resilience in the face of change. As we continue our exploration of the deep, we must remain vigilant stewards of the ocean. The lessons learned from the giants and the minuscule remind us that every creature, no matter its size, plays a role in the grand narrative of our planet's health. The deep sea, with its mysteries and marvels, calls us to engage with its wonders, to learn from its inhabitants, and to protect the delicate balance that sustains life beneath the waves. In this ever-evolving story of the deep, the coexistence of gigantism and miniaturization stands as a testament to nature's ingenuity. Each organism, regardless of its scale, is a thread in the rich fabric of life, contributing to the ongoing saga of adaptation and survival. As we reflect on these themes, we find ourselves inspired to further explore the ocean's depths, to listen to the whispers of its inhabitants, and to cherish the incredible diversity that thrives, both great and small. Chapter 9: Impact of Climate Change on Deep-Sea Life. As we turn our attention to the vast expanses of the ocean, we find ourselves contemplating the profound impact of climate change on its ecosystems. The ocean, a dynamic entity that has sustained life for millions of years, is now facing unprecedented challenges. The delicate balance of marine environments is being disrupted, and the repercussions reach even the most remote corners of the deep sea. Rising temperatures, ocean acidification, and shifting currents are some of the critical changes reshaping these underwater landscapes. Imagine the vast waters warming ever so slightly, a shift that may seem minor at first, yet it sends ripples through the entire ecosystem. The deep sea, often perceived as an insulated domain, is intricately connected to surface conditions. The thermal layers of water, once stable, are now in flux, altering habitats that countless species depend on. Consider the phenomenon of thermal stratification. As surface waters warm, they form a barrier, preventing the mixing of warmer and cooler layers. This stratification can lead to decreased nutrient availability for organisms that rely on upwelling currents to bring nutrient-rich waters from the depths. Creatures that thrive in the darkness, such as deep-sea corals and sponges, find themselves in a precarious position as their food sources diminish. Climate change also brings about ocean acidification, a process that occurs as the ocean absorbs excess carbon dioxide from the atmosphere. This increase in acidity poses a severe threat to calcifying organisms, like corals and certain mollusks, which struggle to build their shells and skeletons. Imagine a coral reef, once vibrant and teeming with life, slowly succumbing to the effects of acidification. The intricate structures that provide shelter and sustenance for myriad species begin to dissolve, transforming a bustling habitat into a desolate landscape. The deep-sea habitats, often thought to be insulated from such changes, are not immune. Hydrothermal vents and cold seeps, unique ecosystems that thrive on chemical energy, are also affected. Alterations in temperature and chemistry can disrupt the delicate symbiosis between chemosynthetic bacteria and their host organisms. These interactions are essential for the survival of many deep-sea species, from tube worms to giant clams, and their disruption could lead to cascading effects throughout the ecosystem. Among the deep-sea inhabitants, unique species have developed remarkable adaptive responses to cope with these environmental changes. For instance, some deep-sea fish have shown a heightened ability to tolerate temperature fluctuations. Imagine the resilience of a deep-sea fish, adapting to changes in its environment with every passing generation. Scientists have observed certain species exhibiting shifts in their metabolic rates, allowing them to thrive in a warming ocean. Yet, adaptation is not without its limits. As conditions continue to change, the question arises, how much can these creatures endure? The potential for extinction looms large for those unable to adapt quickly enough to the pace of change. Species with longer lifespans and slower reproductive rates may find it particularly challenging to keep up. In this ever-evolving landscape, the importance of conservation efforts becomes paramount. Protecting deep-sea ecosystems is not merely an act of preservation. It is a recognition of the intricate interdependencies that exist within marine life. The conservation of deep-sea habitats ensures the survival of species that may hold secrets to resilience and adaptation in the face of climate change. Imagine a world where deep-sea exploration leads to the discovery of new species, each possessing unique adaptations that could inspire breakthroughs in science and medicine. The deep ocean has long been a source of inspiration, and by safeguarding these ecosystems, we preserve not only biodiversity, but also the potential for future discoveries. As we reflect on the interconnectedness of the deep sea and the surface world, one wonders about our role in shaping the future of these ecosystems. What can we do to mitigate the impacts of climate change? Awareness and action are essential to ensure that the deep sea remains a vibrant part of our planet's ecological tapestry. Just as the ocean is a source of wonder, it also calls upon us to be responsible stewards. By supporting sustainable practices and advocating for policies that protect marine environments, we work towards a healthier planet. The creatures that inhabit the deep sea, with their extraordinary adaptations and resilience, remind us of the beauty and fragility of life beneath the waves. The deep ocean is not a realm separate from our own. It is interconnected with the surface world in ways we are only beginning to understand. As we explore the effects of climate change on deep-sea life, we uncover a narrative of survival, adaptation, and an urgent call to action. The impact of our choices echoes through the depths, urging us to consider not just the beauty of these ecosystems, but their importance in the larger web of life. As we continue to learn about the deep sea, let us carry with us a sense of responsibility. Each discovery, each insight gained, deepens our connection to this mysterious world. The stories of deep-sea creatures, their struggles and triumphs, inspire us to advocate for their future and ensure that the wonders of the deep ocean remain for generations to come. In this journey through the depths, we are reminded of the resilience of life and the urgent need for conservation. The deep sea, a realm of extremes, holds lessons that extend beyond its dark waters. As we grapple with the challenges of climate change, let us remain committed to understanding and protecting the intricate ecosystems that thrive in the shadows, for in doing so, we safeguard the future of our planet. As we delve further into the effects of climate change on deep-sea life, it becomes evident that the threats faced by these ecosystems are not merely isolated phenomena, but interconnected challenges that compound one another. The warming waters, rising acidity, and altered currents create a ripple effect that impacts the delicate balance of life in the depths. The intricate relationships among species, forged over millennia, are now tested in unprecedented ways. Consider the role of deep-sea corals, which serve as essential habitats for countless organisms. These corals, with their complex structures, provide shelter and breeding grounds. However, they are particularly vulnerable to changes in temperature and acidity. As the ocean warms, the metabolic rates of these corals increase, leading to greater energy demands. Yet, with the decline in phytoplankton, one of their primary food sources due to changing nutrient dynamics, corals find themselves in a precarious struggle for survival. Imagine entire communities of these majestic organisms, once thriving, now facing the threat of collapse. The phenomenon of coral bleaching serves as a poignant example of this struggle. When stressed by elevated temperatures, corals expel the symbiotic algae that provide them with color and nutrients. This loss not only affects the corals, but also the myriad species that depend on them. The vibrant underwater gardens that once flourished become ghostly silhouettes, devoid of the life and color that once defined them. How can we begin to appreciate the loss of such biodiversity? Each coral bleached is a story of extinction, a reminder of the fragility of life within these deep-sea ecosystems. Moreover, the impacts of climate change extend beyond coral reefs and into the expansive realms of the deep-sea floor. The seafloor, often thought of as a stable environment, is undergoing changes that can have profound implications. The melting of polar ice caps and glaciers contributes to rising sea levels, affecting sedimentation patterns and the distribution of species. As sediments shift, so too do the habitats that many organisms rely upon for survival. Imagine a landscape of shifting sands, where once familiar territories are transformed into unrecognizable terrains, leaving creatures struggling to adapt to their new reality. Among the fascinating inhabitants of the deep sea are the cephalopods, such as octopuses and squid, which exhibit remarkable intelligence and adaptability. These creatures, with their ability to change color and texture, also face challenges as their environments change. Research has shown that cephalopods may be particularly sensitive to ocean acidification, affecting their cognitive functions and behaviors. How might the loss of these intelligent beings, capable of problem-solving and complex interactions, reshape the ecosystem? The ripple effects of their decline could reach far beyond their immediate surroundings, impacting the entire food web. As we reflect on these intricate dynamics, the question of conservation arises. What measures can we take to protect these vulnerable ecosystems? The importance of establishing marine protected areas cannot be overstated. These sanctuaries provide refuge for species, allowing them to thrive without the pressures of fishing and other human activities. By creating safe havens, we grant these ecosystems the opportunity to recover and adapt, fostering resilience in the face of climate change. The story of the ocean is not solely one of struggle. It is also one of hope and potential. Scientists are uncovering the resilience of certain species, revealing their capacity to adapt to changing conditions. For instance, some deep-sea fish have demonstrated remarkable plasticity in their reproductive strategies, allowing them to adjust their spawning times in response to shifts in environmental cues. Imagine these creatures, navigating the changing rhythms of their world, finding new ways to ensure the survival of their lineage. The adaptations we witness in the deep sea remind us of the intricate web of life that connects all forms of existence. The stories of these organisms, their challenges and triumphs, echo the resilience of life itself. As we continue to explore the depths, we must commit to understanding and preserving these ecosystems. By supporting research and conservation efforts, we can contribute to the protection of the deep sea, ensuring that it remains a source of wonder and inspiration for future generations. In our quest to comprehend the complexities of deep-sea life, we must also consider the role of innovation and technology. Advancements in underwater exploration have opened new doors, allowing us to study these environments more closely than ever before. Remote-operated vehicles and submersibles equipped with cutting-edge sensors provide invaluable insights into deep-sea ecosystems. How do these technologies enhance our understanding of the challenges faced by deep-sea species? They illuminate the hidden lives of these creatures, revealing their behaviors and interactions in ways we never thought possible. As we gather data and analyze trends, the knowledge we acquire becomes a powerful tool in our conservation arsenal. With each new discovery, we deepen our appreciation for the wonders of the deep ocean and the intricate connections that bind all life. The urgency of our task is clear. The choices we make today will reverberate through the depths of the ocean for years to come. Imagine a future where vibrant deep-sea ecosystems flourish, supported by our collective efforts to combat climate change. A world where the extraordinary adaptations of deep-sea creatures inspire us to innovate sustainable practices and policies. The potential for healing and rejuvenation exists within our grasp, awaiting our commitment to protect these vital ecosystems. The deep sea, with its mysteries and marvels, calls us to action, urging us to be caretakers of the ocean and its inhabitants. In navigating the complexities of climate change and its effects on deep-sea life, we find ourselves at a crucial juncture. The stories we uncover, the connections we forge, and the actions we take will shape the future of these ecosystems. As stewards of our planet, let us strive to ensure that the deep sea remains a sanctuary of life, a testament to the resilience of nature and the enduring spirit of all living beings. Chapter 10: Future Exploration, Unveiling the Deep Sea Mysteries. As we stand on the threshold of a new era in deep-sea exploration, the advancements in technology are unlocking the secrets of the ocean's depths like never before. Imagine submersibles gliding through the inky blackness, equipped with high-definition cameras and sonar systems that can capture the intricate details of the seafloor. These innovations are not merely tools, they are bridges connecting us to a world that has remained largely hidden from our view. The advent of remotely operated vehicles, or ROVs, allows researchers to reach depths that were once deemed inaccessible. Equipped with robotic arms and precision instruments, these vehicles gather samples and data, revealing the ocean floor's topography and the diverse life forms that inhabit it. Consider the recent development of autonomous underwater vehicles, or AUVs, which can traverse vast distances, mapping the seafloor while collecting valuable scientific data. These vehicles operate independently, powered by advanced AI that enables them to navigate complex underwater landscapes. The ocean's depths are now being charted with unprecedented accuracy, revealing features that can rival the most stunning landscapes on land, such as underwater volcanoes and expansive hydrothermal vents. In the past few years, groundbreaking discoveries have emerged from these explorations, illuminating the mysteries of the deep sea. Researchers have unearthed new species that challenge our understanding of life in extreme environments. Imagine the awe of encountering an organism that thrives in the crushing pressure of the abyss, like the giant tube worm, which can grow several feet long and lives near hydrothermal vents, relying on symbiotic relationships with bacteria for sustenance. These bacteria convert the chemicals spewed from the vents into energy, creating a vibrant ecosystem in a place where sunlight never reaches. One particularly exciting discovery involved an entirely new ecosystem thriving in the depths of the Mariana Trench, a place that had long been thought of as desolate. Here, scientists found strange and beautiful creatures, such as the amphipod known as the deep-sea snailfish, which has adapted to survive the extreme conditions of its environment. These discoveries not only broaden our understanding of biodiversity, but also raise profound questions about the origins of life itself. What can the unique adaptations of these creatures teach us about resilience and survival in the face of adversity? Ongoing research into deep-sea life is essential for several reasons. First, understanding the intricacies of these ecosystems can provide insights into the processes that govern our planet's health. The deep ocean plays a crucial role in regulating climate by sequestering carbon and influencing weather patterns. By studying these ecosystems, we can better comprehend their contributions to global systems and the potential consequences of environmental changes. Moreover, the deep sea serves as an extraordinary laboratory for scientific inquiry. The organisms that inhabit these depths often possess unique biochemical properties, making them valuable for a range of applications, from pharmaceuticals to biotechnology. For instance, the enzymes derived from extremophiles, organisms that thrive in extreme conditions, are being utilized in industries such as biofuels and food processing. The potential benefits of these discoveries extend beyond mere scientific curiosity. They hold promise for addressing some of humanity's most pressing challenges. Imagine the possibilities of harnessing the unique properties of deep-sea organisms to develop new medications or innovative materials. The discovery of compounds with antimicrobial properties in the depths could revolutionize medicine, providing new avenues for treating infections that are resistant to conventional antibiotics. As we explore the ocean, we may uncover solutions to problems that have long plagued society. The importance of continued research in the deep sea cannot be overstated. Each expedition into these uncharted waters brings with it the potential for groundbreaking discoveries. Yet, while we unveil the mysteries of the deep, we must also consider the impact of human activity on these fragile ecosystems. As we extract resources and explore these depths, we must tread carefully, ensuring that our quest for knowledge does not come at the expense of the very ecosystems we seek to understand. As we look to the future of deep-sea exploration, we find ourselves at a crossroads, with the potential for profound discoveries and the responsibility that comes with them. The ocean is a vast, interconnected system, and every new piece of knowledge adds to the intricate puzzle of life on Earth. What wonders still lie undiscovered in the depths? What adaptations have yet to be revealed? Each dive into the abyss brings us closer to answering these questions, illuminating the wonders of a world that remains largely unexplored. As we ponder the future of deep-sea exploration, we are reminded of the words of oceanographer Sylvia Earle, who said, "With every drop of water you drink, every breath you take, you're connected to the sea." This connection urges us to deepen our understanding of the ocean, to embark on a journey that intertwines science, discovery, and stewardship. The deep sea is not just a realm of mystery, it is a vital part of our planet, deserving of respect and protection as we unveil its secrets. In the coming years, as technology continues to advance and our curiosity drives us deeper into the ocean, the potential for discovery is limitless. Each new exploration promises to reveal not only the wonders of the deep, but also the interconnectedness of all life on Earth. The stories waiting to be told beneath the waves are as diverse and intricate as the ecosystems themselves, offering glimpses into the past, present, and future of our planet. The deep sea is a realm of extremes, where life adapts in ways that challenge our understanding of biology. As we continue to unveil these mysteries, we are not only expanding our knowledge, but also fostering a sense of wonder and responsibility for the preservation of these unique environments. The journey into the depths is just beginning, and with each dive, we are reminded of the beauty and fragility of life in the ocean's dark embrace. What will we discover next? What lessons will the deep sea impart upon us as we continue this exploration? The future is bright, and the ocean awaits, a treasure trove of secrets just waiting to be uncovered. The deep sea, a realm that feels almost alien, continues to defy our expectations about life on Earth. With the advancement of technology, researchers are not only uncovering new species, but are also beginning to understand the complex relationships that bind these organisms to their environment. For instance, the discovery of deep-sea corals reveals a thriving habitat that supports a myriad of marine life. These corals, often mistaken for their shallow-water cousins, possess unique adaptations that enable them to survive in near-freezing temperatures and complete darkness. Imagine a coral garden, where colors bloom in shades of white, pink, and orange, illuminated only by the faint glow of bioluminescent creatures. Unlike their shallow-water counterparts that rely on sunlight for photosynthesis, these deep-sea corals capture food particles from the water, showcasing an ingenious adaptation to their environment. As we explore these coral ecosystems, we are reminded of the delicate balance that sustains life in the depths. Coral reefs, though often thought to be confined to warm, sunlit waters, reveal their own mysteries and significance in the deep sea. They contribute to biodiversity, serving as habitats for fish, crustaceans, and various other organisms, forming a hidden network of life that thrives in the harshest of conditions. It is essential to recognize the role of ongoing research in these underwater ecosystems. Each new expedition into the abyss brings the potential for revolutionary findings that can reshape our understanding of marine biology. Imagine the thrill of uncovering a new species, one that possesses unique traits capable of informing biotechnology or medicine. Scientists have identified enzymes from deep-sea organisms that have the potential to revolutionize industries, from pharmaceuticals to food production. The unique properties of extremophiles, for example, offer pathways to develop new antibiotics and treatments for diseases that have long resisted conventional medicine. The beauty of this exploration lies in its unpredictability. The ocean is a living laboratory, constantly presenting new challenges and surprises. Each discovery adds to the growing body of knowledge about the deep sea, offering insights into evolutionary processes, ecological interactions, and the resilience of life. As we delve deeper into this uncharted territory, we are reminded of the words of marine biologist Rachel Carson, who once said, "The sea is a mysterious and beautiful world, a world that must be understood and protected." The potential benefits of deep-sea discoveries extend far beyond scientific curiosity. They hold the promise of improving human lives. Imagine a world where the secrets of the deep can lead to breakthroughs in sustainable energy sources or innovative materials that minimize our environmental footprint. The deep sea may harbor organisms that can produce biofuels from waste, creating a sustainable cycle that benefits both humanity and nature. Such breakthroughs are not mere fantasies. They are possibilities that await us as we continue to explore the ocean's depths. However, as we uncover these treasures, we must remain vigilant stewards of the ocean. The urgency of our responsibility cannot be overstated. The delicate ecosystems that flourish in the dark are increasingly at risk from human activities such as deep-sea mining, pollution, and climate change. With each dive, we are granted a glimpse into a world that is both beautiful and fragile, urging us to act with care and consideration for the future. Imagine the profound loss we would face if we allowed these unique habitats to be destroyed before we could fully understand them. The interconnectedness of the deep sea with our global environment emphasizes the importance of informed conservation efforts. We must advocate for protective measures that preserve these underwater ecosystems while supporting sustainable practices that benefit both humanity and marine life. By fostering a sense of wonder and stewardship, we can inspire future generations to continue the exploration of the deep sea, ensuring that its secrets are not lost to time. As we imagine the future of deep-sea exploration, we are filled with a sense of hope and anticipation. What new adaptations will we discover in the creatures that inhabit these depths? What unknown ecosystems await our discovery? The ocean continues to surprise us, revealing its wonders slowly, like the unfurling petals of a flower in the light of dawn. With each expedition, we are reminded of the vast potential for learning and understanding, urging us to keep pushing the boundaries of our knowledge. The stories we uncover in the deep sea are not merely about the organisms themselves. They intertwine with the history of our planet and the future of life on Earth. As we explore, we gain insights into the resilience of life, the intricate connections that govern ecosystems, and the balance that sustains our shared environment. The deep sea serves as both a mirror and a window, reflecting the challenges we face while offering glimpses of hope and innovation. With every dive into the abyss, we are not just exploring the depths of the ocean, but also the depths of our understanding. The potential for discovery is immense, and the lessons we learn from these explorations can guide us toward a more sustainable future. What wonders lie beneath the waves, waiting for us to unlock their secrets? Each exploration offers a promise, a chance to connect with the profound mysteries of the ocean and to champion the conservation of our planet's heart. The journey is far from over. It is merely the beginning of a deeper understanding of life, both within and beyond the depths.